All right. Good afternoon, everybody. Good afternoon. It's 6:15. We are going to begin day two of this final week leading up to our exams, which is going to be next week Tuesday. And for tonight, we are going to be digging deep into vectors and matrices. So last night, we were able to do a little bit of, well, not a little bit of. We went into functions and relations, which those questions last night you are particularly going to find them on question 4 and question 8. So whatever we did last night, you will find those questions on question 8 and question 4. All right. So once you find your time in your own space and time to review that video, it will be made available at 9 p.m. tonight. Right? So you'll have access to it on YouTube, and then you can watch it within your personal time on space. But it will be released tonight at 9 p.m. All right, so you can check out to that. But for tonight, we are going to be attacking question 11, which is vectors and matrices. We'll be attacking question 11, which is vectors and matrices. So after tonight, it's either you really like vectors and matrices, or you really do not like vectors and matrices. That's just where it's at tonight. Or you're just going to try to meet it somewhere in the middle. Remember, tonight's class is going to be extensively about that. So you're going to be seeing the same thing repeating itself every single question again and again and again. All right? So as you're going through these questions, please use your notes that you have that's related to whatever we've been taught to participate in the chat or through your microphones. Or if you are seeing them for the first time, which is highly unlikely, because I only have a few outside students in here. Majority of who is in here are students who would have been in my class throughout the year. So if you're seeing it for the first time, or you are seeing some concepts that are not sticking, feel free to write them down and study from whatever it is that you have or we're going to be doing tonight. Okay? All right, so let's get into it. All right, so again, we're starting from 2010, going all the way up. These questions are, in my opinion, I think they are good questions to give us some strong foundation. All right, so let's get into it. All right, good. So it says here, A and B are two 2x2 matrices such that the matrix A is 1, 2, 2, 5, and the matrix B is 5, -2, -2, 1. For 2 marks, you are required to find AB. All right? And so once you have 2 matrices that are joined together, that implies that we need to multiply these 2 matrices here. So therefore, to set this up now, we're just going to simply take the matrix A, which is 1, 2, 2, 5, right beside the next matrix, which is 5, -2, -2, 1. And we're going to use the row by column technique. All right, to multiply 2 matrices, we must use each row in the first matrix to multiply the columns in the second matrix. So watch the pattern now, people. So those who are seeing this for the first time, or you just, focus, guys, focus. So we're going to be using this row here, and this row will be used to multiply this column down here. All right? And the fundamental rule of this is to ensure that when you're multiplying, the first term has to match with the first term, and the second term has to match with the second term. So look at this now. The first term over here must multiply the first term over here. And the second term over here in this row must multiply the second term in the column there. So that's very important. Again, one last time. The first row, which I have underlined here in blue, must be used to multiply the first column in the second matrix, which is what I have over here. But whilst you line that up, remember that the first in the row must match with the first in the column, and the second in the row must match with the second in the column. And you have to repeat that process every time you multiply. So let's do that multiplication now. Matching this now, 1 will multiply 5. We'll end up with 5 plus 2 will multiply minus 2. I'm going to end up with negative 4. So that is for the first row, first column. I'm going to erase this right now. Sorry guys, give me a second here. All right, so I'm going to erase this right here. So now I'm still on my first row. I've just completed my multiplication with my first column. I'm just going to simply slide down the second column here. And then I'm going to do it again. First have to match with first, and second has to match with second. Let's multiply then. So 1 must multiply negative 2 to give us negative 2. Plus 2 must multiply 1 to give us 2. All right. So now we have completed row 1 with column 1 and row 1 also with column 2. We're going to switch over now. And we're going to do the next thing. We're going to go, oops, sorry. So next thing that we're going to do now is we're going to go to the second row. Right, so that's a new row. And then we're going to slide down the first column again, like that. So 2 will multiply 5. The rule stands first with first, second with second. 2 times 5 is 10. And that's going to be added to 5 times negative 2, which is negative 10. All right, and then finally now, we've finished with the first column. We're going to go to the final column here. So now we're going to go again, first with first, second with second, first with first, second with second. So 2 times negative 2 is negative 4, plus 5 times 1 is 5. All right? This requires some practicing. This requires some practicing. So if no practice, if you don't practice it, you will always going to make that mistake of multiplying the wrong numbers. Now 5 plus negative 4 is going to give us 1. 5 plus negative 4 will give us 1. Negative 2 plus 2 will give us 0. 10 plus negative 10 will give us 0. And negative 4 plus 5 will give us 1. And that is your answer. All right, so the matrices product is 1, 0, 0, 1. Okay, good. Now, if you are still confused, you need to put aside some time and you just check out a personalized video that will explain to you just how to multiply matrices alone. All right, but so we have a lot of questions to do tonight. So stay sharp. All right, stay focused. All right, so that takes care of this question. Now, the next question here is going to be to find B inverse. So we need to find B inverse. So this symbol here, just in case you do not see the word inverse, that symbol means the inverse of the matrix. All right? And so to find the inverse of any matrix, there's two things we're going to need. We need to find what is known as the determinant of B, and we also need to find the adjoint of B. So you need to ensure that you know how to find these two things in order to find the inverse. All right, so now there is a formula that we had derived for how to find the determinant. The determinant of a matrix is obtained by using the first entry the determinant of a matrix is obtained by multiplying. The determinant of a matrix is obtained by taking the first times the last minus the second times the third. All right? And for those of you who are wondering the first and the last and the second and the third, the first is this, second is that, the third is this, and the fourth is that. So A, B, C, and D. Okay? That's what we call the first, second, third, and last entries. So let's plug that in then. A is going to be 5, and D will be 1. B is negative 2, and C, let me just write that a little better, please. So A is 5, and D is 1, minus B is negative 2, times C is also negative 2. 5 times 1 is 5, and negative 2 times negative by negative, these three negatives here. Negative by negative is positive, times the negative is negative. So 3 negatives gives you back a negative. So that's 5 minus 4. So the determinant here is going to simply be 1. So that's my determinant. Now the adjoint of B is where we are going to switch the lead. So pay close attention. To find the determinant of B, we're going to switch 5 and 1. All right, make jottings, people. We're going to switch 5 and 1. So we're going to end up with 1 up top, 5 down at the bottom. And then we're going to change the signs of B and C. So B is a negative 2, we're going to put 2. And C is a negative 2, we're going to put also 2. So remember, you switch the lead and you change the signs of the non-leading. So you switch this. So this one is the one that you switch, or you interchange. So you switch that one, and you change the signs of this one. So you basically change signs of this one. So you change signs. So make sure you familiarize yourself with that. So therefore then, what's our final answer? B inverse is equal to 1 over the det times the ADJ. So the formula for inverse is 1 divided by the determinant of that matrix times the ADJ. Now, 1 over the det is just simply going to be 1 over 1 multiplied by the ADJ, which is going to be, in this case, 1, 2, 2, 5. All right, guys, can you please control your microphones? Thank you. Ashani, can you please control your microphone? I remember, guys, that when you're logging in, please ensure that your microphone is on mute. You will put out your personal business on YouTube, you know. So be very, very mindful, okay? All right, and therefore we know that 1 divided by 1 is just simply 1. And when you multiply anything by 1, you're going to get the same thing. So there's no much calculation to do here. The answer is just simply going to be 1, 2, 2, 5. Remember, 1 over 1 is 1. And when you use 1 to multiply the matrix, you end up back with the matrix. Okay? And that is your answer for the inverse of the matrix. Okay? Now you'll notice here that it only works 1 point. So, sir, do I have to do all of that for 1 point? Actually, no. Because I'm teaching why I'm going through it step by step. Because this is like a reteach for me. Because you probably don't realize that these two matrices are actually the same thing. If you notice that 1, 2, 2, 5, the matrix over here is actually the adjoint of the matrix over here. But not a lot of students are going to pick it up like that. So even though it's worth 1 point, unless you're very experienced to pick up that pattern there, and it's very rare that they give you questions like these where they're giving you the matrix and giving you the adjoint. You have to be really into matrices and really, really deep and really understand and have that sense of picking up patterns to see that these two matrices are the same. So, some questions, as you can see, it's just 1 point. There must be a reason why they gave you 1 point for that. But I'm not teaching it from that point of view. I'm teaching from the point of view as if you've never seen this before or you've seen it already, but you want to, relearn it from scratch again. Okay? So that's it. All right. Please take a screenshot if you need it. I don't know, because if you need it. I prefer if you're right while I'm teaching, because when I do that, it really exercises the brain. Please don't sit down and just watch me writing stuff on the screen. And unless you're at work and you can't really do that, then as long as you're accessible to a pen and paper and a book, you should be writing while I'm working, so you can stay active. Okay? So just to create some space here. All right, good. Now, the next part of the questions, let me just cross over what I've done already. That's done. Now, it says that we are given 5, -2, -2, 1. And 5, -2, -2, 1 is multiplying xy. And this is going to be equal to 2, 3. They said that we should write x and y as a product of two matrices. So write x and y as a product of two matrices. This is interesting. Write x and y as a product of two. Oh yeah, I know what I mean. Okay. All right, so let's go back, guys. This is the last topic that we would have taught in matrices. Now, hopefully you can recall when we spoke about solving simultaneous equation using matrices. And we said that every simultaneous equation written in matrices is written in the form AX equals B, where this matrix here, or the A here, represents the numbers that are in the bracket here. So this would be your A matrix. So this would be your A matrix. This would be your X matrix, and this would be your B matrix. So it's AX equals B. Now I gave you all a shortcut for how to get to the answer, and we stated that X must be equal to the inverse of A times B. All right? So that's the formula for finding the matrix that is X here, which is always the matrix that is right here. So the formula, or the shortcut, the legal shortcut, that is to finding a matrix that is in simultaneous matrices form, is to bring this matrix over here. Watch me now. Bring this matrix over here, and when you bring it over there, it should go over that side as its inverse form. All right. So X must be equal to A inverse times B. So down here now, let me just this bit of cleanup. So down here now, what they want you to do for this question is that they want you to bring this matrix right here, bring this matrix. They want you to bring it over here, but they want you to bring it over there in the inverse form. Now, if you pay close attention, right, you'll realize that this matrix right here is the same thing as this matrix up here. The questions are connected. They're the same matrix. And in the previous question, we had already calculated the inverse of that matrix. It was the answer you got for the previous question. Now, the inverse of this matrix is the answer you got for the previous question we just worked out. And the inverse of that matrix was actually this matrix over here. 1, 2, 2, 5. We just worked it out a while ago. Part 2, when we did the 1 over determinant times the adjoint, and we get 1 over 1 times something, and we get back this thing here. That is the inverse. So A is actually the inverse of B. So when they want you to write it as a product of two matrices, what they want you to do is to do this. They want you to say xy. They want you to say xy is equal to the inverse of this, which we know is A matrix, which is 1, 2, 2, 5, and times it back by 2, 3. That's what they want you to write down. That's what they're asking for. So this third question here is just simply telling you to write down the inverse of B times this matrix right here. You can call it whatever. Inverse of B times whatever this matrix is right here. All right, so that's what they want. Okay, so again, feel free to. Just a minute, guys. Just a minute, please. All right, my apologies. My apologies. I'm seeing some. I'm so sorry. I wasn't paying attention to the chat. Daniel was saying, wouldn't it be -2? What are you referring to, Daniel?
I'm talking about the part when the A inverse. Would it be 1, -2, -2, 5? Yeah.
Give me a second. Let me jump back on the screen. You're talking about part 2?
Yeah, no, 3 when you're trying to find x, y.
No, we're not trying to find xy. Then only someone just write it in this form first. It is down here now that we're going to find x and y. When them say hence, calculate the values of x and y. So our only job in this part right here, the only job in this part here was just to find or write it down in a metric form. So this is our answer for this right here.
So that's why I'm talking if it would have been -2. The inverse.
Oh. No, but remember that we found the inverse of the matrix already. Now. Remember in part 2, Daniela, when part 2 says find the inverse of B, what did we get for part 2 when we found the inverse of B? What was the answer that we got?
We got 1, 2, 2, 5.
Exactly, which is the matrix A over here.
Okay.
So when we bring it over here in the inverse form, we're actually writing on the matrix A, which is 1, 2, 2, 5. And we times it back by 2.
I thought you were to find the inverse of 2, which would be what B is.
Oh, no.
Okay, then.
All right, so that's it. All right, like I said, guys, anything that is unfamiliar or new, it might have been for two reasons. Either you never come to the class at all, or you've never taken on to any of the videos or stuff. So you have the responsibility of checking that out from the fundamental point of view, because it was taught from a fundamental point of view before we got to this stage. All right, now the last thing here is that you should hence calculate the values of x and y. So to calculate the values of x and y, all we need to do is just multiply these two matrices right here. Just multiply them. And that is simply asking us to go row by column. That's it. So let's go row by column now. First with first, second with second. 1 times 1 is 1. Sorry, that's incorrect. It is 1 times 2 is 2 plus 2 times 3 is 6. Remember, first with first, second with second. So look now. First with first, 1 times 2 is 2. That's what I have right here. And second with second. That's second with second, 2 times 3. That gives us 6 right here. Okay. All right, put that in a matrix, and then we end up with the bottom piece now.
So I got 2, 6, 4, 15.
No, the 2 should be added to the 6, Daniela, remember.
Oh, 8, 19.
That's correct.
Okay.
That's 2. So 1 times 2 is 2, plus 2 times 3 is 6. So we're going to add those, and then 2 times 2 is 4, and 5 times 3 is 15. So your answer then is simply going to be 8, 19, and that's it. Okay? So that is how you would answer a question like that. So they have some tricky little ways where they can ask the matrices. You just have to be exposed and get yourself familiar with it. Okay? Now, as per usual, remember that matrices is matrices. Yes, Javar, me so well gone. Yeah, man. Remember, I'm teaching it as if at the first time here. So I change the second diagonal. Okay. Apple, this is this is 2010 Apple. 2010. So working from 2010 come all the way up to 2017. All right, cool. So that is out of the way. Now, as you would have already been informed, that if you are in fact a fan, or you prefer this topic over all the other topics that you would have been exposed to, it is tied with vectors. So if you're fond of matrices, you have to find some sort of likeness for vectors. All right, so let's zoom up on here for vectors. The diagram below, which is what you're looking at here, the diagram below, not drawn to scale, shows triangle JKL. Give me a second, guys. 1 second. Okay. All right. So the diagram below, not drawn to scale, shows triangle JKL, which you can very clearly see on screen. So we have the points J, K, and L. So we have the points J here, K, and L. You can see those points. All right, lovely. Now let's read here. It says that M and N are points on JK and JL respectively. We've seen this thing before. Respectively. That means in the order that it's listed. So look at the order now. M and N, JK and JL. What that means is that M is going to be on JK and N is going to be on JL. That's why the word respectively is there. It is trying to tell you that it's going to be in order. So we know that M, as you can see, you don't see an M there, so you're the one that's going to be required to put it there. So M is going to be on JK and N is going to be on JL. But look at the position now. This is what we refer to as the biconditional statement, and this is where the lows for vectors. Please control your microphones, guys, when you're coming in The class, thank you. Ajanai, thank you. Okay, all right. So this part here is where the loss for vectors usually comes up. The biconditional statement. Interpreting this part is not anybody's favorite, but if you catch it and you start to get a hang of how to interpret what it means, then you're gonna find vectors one of your favorite topics. Believe me. If you can just bypass this pothole here, you'll be okay. Now look at what I'm saying now. So now we're told that M is going to be on JK, but look at how it's on JK. They're saying that from J to M, so from this point to wherever you're going to put M, it should be 1/3 of the entire line. So this 1/3 right here, ladies and gentlemen, folks, this 1/3 is telling me that the line has been divided into 3 equal parts. That's what it means. And 3 equal parts doesn't mean that to be accurate, but you just want to have an idea of where it's going to be. So I'm going to divide the line here. So this is going to be my 1/3. This is going to be my 2/3. Okay. So therefore, J to M. So J to M, I'm going to put M right here. And so what they're trying to say here is, and let me show you here. So what they're trying to say is from J to M right here, from J to M right there, so it is going to be 1/3 of the entire line. So JM is 1/3. So whatever the distance of JK is, when we find it, we know that JM will be 1/3 of that very bold line that I have right there. It's going to be 1/3. So what am I going to do now just to make life easy for myself? I'm going to put right here 1/3 of something. We don't know whether something there be yet. That something will be whatever goes here. So until we find out what is JK, we don't know what to put in this bracket right here. All right. So we're going to hold off on that for a second. Now let's move to the next part here. It also says then that JN now, right? It's remember that N is on JL, but N is going to be on JL. So in other words, then JN, let me just use a different color here. So this is JL right here. That's JL right there. Zine? And what we know for sure, let me just not put it there. This is JL right here. Give me a second. Need to use some proper markings so you guys can see what's going on. So this distance right here is JL, right? I'm gonna use the markings here. So from here to here is JL. Not true? Boom. But what we know is that N is going to be on JL, and it is on it in such a way that it is 1/3 of the entire line too. So I'm gonna divide my line here into also 3 equal parts. Here so, and here so. It doesn't have to be accurate, but I just want to have an idea. And so I'm gonna put N right here. So why am I putting N there? Why? Because from here so to here so from here so to here so is 1/3 of the entire line that's right here. It's 1/3 of that line. So in other words, then I'm going to take 1/3 and put it right here. 1/3. It's going to be 1/3 of something. And that something, I don't know what that something is as yet because I don't have this something here. So until I find it, I won't know what to put in that small bracket right here. When I find it, I'll know what to put in there. Okay? All right, cool. All right. Is everybody okay up to this point? Don't worry about what will come next, Is everybody okay up to this point?
Yes, sir.
Yes, sir.
Yes, sir.
Once you're good up to that point, you see, once you can figure out them little pieces of the puzzle, is once you can have. Oh, give me a minute again, guys. I'm so sorry.
Can I recap that, please?
What do you mean recap? What do you mean recap?
When you say 1/3, the 1/3 that give me problem because there's no other number. The
But
1/3 that give me
we have to get the number first. We haven't got the number yet, Daniela. What we know is that the distance is going to be 1/3 of that entire distance. We haven't gotten that distance yet. We're currently just interpreting what the 1/3 means. So by finding the position, we only need to find the position of n. If you notice where I put n, all of that discussion there was purposely just to find out the position of n. So that's why we put n right there, and we put m right there. We so forward. Give me 1 minute, please.
all right. Me? Why? They are concentrate, sorry. They are if you swear come back, so they are concentrate to play drum.
Daniela, your mic is on.
Daniela, I'm going to ask you kindly please to control your microphone. The class is being recorded. Thank you.
I'm sorry.
All right, sorry guys, I am balancing the class that I'm doing right now, the one that is going concurrently on TikTok. So if I jump out one and again, I have to be balancing both devices. Okay, so back to where we're at. So I believe everybody said that they're okay up to this point where we're at, right? Why we put m weight there? Why we put n weight there? And where that 1/3 come from? It's coming from the biconditional statement. Now, as long as we can wrap our minds consistently around this biconditional statement, everything else is a piece of cake. Watch this. Look how beautiful this is going to be now. Them say copy the diagram in your answer booklet and show the points M and N, which we have successfully done already. We've shown exactly where M is and where N is. We've shown that N is right here, and we've shown that M is right here. Have we gone with the 2 marks? That's all. Now, they're saying to us that given that JM, that's the vector JM, is U units long. So the whole entire vector JM, so where's JM? JM now. So we're told here that JM is U. So JM is U. So right here, so is U. So what I'm going to do is that I'm going to put here, I'm going to put U here. So let me just erase this. Give me like a second here. Let me just clean this up. Let me clean up my diagram first. Those highlighters was just to get you to understand where the M and N is. Let me fix this up better. All right, so now we agree that M is actually here and N is actually here. That's approximately about 1/3 of the line. Not accurate, but it's about 1/3. All right, so we are told that JM, so we are told by the from the question that JM is U. So that means that from here to here, so from here to here, so is U. So from here to here is U. And we know that this is 1/3 of the line. So what do you think the entire line is going to be? Let me see if I can figure that out. If JM is U, what would be the entire distance of this line right here?
1/3 plus U.
Try again.
3U.
Correct. Excellent. It would be 3U. It would be 3U. I'm sure you're going to ask me, how, sir? How? The entire line has to be 3U. Because look, if the entire line is 3U, what is 1/3 of 3U, Jabari? What is 1/3 times 3U? Cancel, cancel. So it'll be U. So then do them I try to trick you. What you would have expected him to do? Had I told you that JK is 3U, you would have known that 1/3 of 3U is U. What they did is that they give you the information backwards. So they gave you JM, and instead of them try to get you to say 1/3 of U, when you're supposed to just multiply it by 3. So you have to watch out for those little tricks. Okay?
Yes.
So because JM is U, the entire line has to be 3. So the entire line, is 3 times this, The entire line is 3 times that, But because of what them gave you the information backwards. So they give you the information backwards for you to reverse it. So instead of saying 1/3, you just multiply by 3. All right? And then the next one is JN is V. So JN is V. So if JN is V, what do you think the entire line is going to be?
V.
Correct. 3V. Very good. 3V. Right? The entire line is 3V. All right. Solid. So now we get through all that rigmaroles now. Them say write in terms of U and V. We've spoken about this thing with them say write in terms of. Write in terms of, meaning that the answer that you're going to write down on paper to say this is the answer, it must have the letter U in it, and it must have the letter V in it. Them say them want JK. So we know that JK, let's write down something here. We already know, look at them right up here saying now. JM is 1/3 JK. So JM, so we already know that JM, you can just write down your answer, because I know you know what the answer is, because we figured it out already. But how do we mathematically write this down? So we're going to use the biconditional statement that was given to us. They told us that JM is 1/3 JK. And we were just told that JM is U. So I'd put U underneath this. Let me put an arrow. Okay. So we were just told that JM is U. So them just tell us that JM is U. So put the U right underneath here. And that's going to be equal to 1/3 JK. We don't know what that is. 1/3 JK. So obviously, if we want to find JK, we'd have to just multiply both sides by 3. That's the only way. That's the only way to get JK by itself. You'd have to multiply by the number that's at the bottom. So that's why then JK is equal to 3 times U, which is 3U. So that's how mathematically we would get the answer. But how much marks is it worth? 4. So I'm going to say probably we are just 1 for this, and then probably give you 2 for that, and then probably 1 for that or something like that. Okay? All right. So that's 1/3. That's 3 times U. 3 times U. 3 multiplied by U, which is 3U. Good. Mn. Mn, to move from M to N, would have to have a line that connects M to N. So we have a line joining from M to N. We'll put on the arrowhead, M to N. Do you see a triangle that can take you to N, moving from M without going straight? Give me a triangle that can take us to M. Give me a triangle, a route that can take me straight to N without going, that can bring me to N without going straight from M to N. Where can I go?
So you can
MJ.
go from J to M and then from M to N.
Come again. I'm already at M, you know. At M, now. So tell me where I need to go. I need to go from M to where?
Oh, M to J. And
M
then
to
from
J.
And J to N.
That is correct. Wonderful. Give me a second. Look at me. I have a knot right here that's bothering me. Oh, very good, guys. Very good. So, therefore, then, we are going to say that M to N is actually equal to M to J plus J to M. J to N, sorry. All right, and MJ, if you look back on our diagram,
Sir,
yes.
So it does mention if it's negative or so,
If what is negative?
the line where it's going from. So
No, you're going to figure that out, you know. Because we are, okay, so you're saying, the arrowhead was missing. Okay, my bad. The arrowhead is, all right, good. So the arrowhead were supposed to be there in the first place. All right, so because J to M is U, going backwards is going to be negative U. So that's going to be negative U. And then as you can see here, Jn and U are going the same direction. You're going the same direction as Jn, and that's going to be V. And that's it. The answer is negative U plus V.
I have a question.
Yes, Shamir.
How do we determine which way the arrow goes if it doesn't come labeled like that?
Well, they gave us from here. Yes, how do you know where the arrow goes? This is known as the tail, and this is known as the head. So if you see JM, it means that you're moving from J to M.
Okay.
Yeah, and J to N, that means you're moving from J to N.
Okay, thank you.
You're welcome. KL now. Yes, question.
I feel like this is what this gonna give me problem. I'm okay with matrix, but I don't understand nothing here now.
and arrows. I don't understand either, sir.
I mean, remember, if it's new, you know, you have to carefully use the word understanding, because if it's the first time you're learning it, it's going to be hard. So you have to take the time out to watch the fundamental point of view of matrices, of vectors. So you have to go back. If it's challenging, you have to go back to where it started from. So let me help you out. Let me here. So if you use the word I don't understand, it means that maybe you never learn it from the fundamental point of view. So I'm putting up something on screen here, and I'm going to go on my page. I'm going to show you where everything starts from. Give me a second here. So if you know you're okay with matrices, you have to be okay with vectors. All right. So where does it start from? Well, all you do is just take some time out of your personal and busy schedule and go all the way back to right here. Right here, part 1. This thing here that says vectors for C6 students part. The one that is in the second row, and you see me in the white shirt and the black underneath. That video explains the fundamentals of vectors. Once you have successfully watched that and give you some idea, then you can come back up to this one up here that says vectors for C6 students, part 2 of part 3. And then you'll get some more clarity that you need. But you have to spend some time locking in for that. Okay?
Okay, sir.
Okay, good. But in the meantime, still just go and see if you can survive tonight's class. Don't 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 accommodate any negative thoughts about it, because you only say that now until you really start get it. Okay. All right.
Okay, sir.
KL. All right, cool.
Sorry.
KL. Yes, question.
So, when it says, for the second one, it says right in terms of UN, an expression for
Yeah.
MN. When you're going from M to J, why didn't you use negative 1/3? Why didn't you use negative 1/3?
Why did I not use negative? Negative what?
1/3, because it says from J
No,
to M.
no, we never use the 1/3, because we were told that the distance from there is 1/3 of 3u. So we were told that, and that's a good observation, good question. So why we never use the 1/3 is because we already calculated the values already. We never, in the start, we never knew what the 1/3 of what it meant. But once we calculated this distance here, we already used the 1/3, and we knew that 1/3 of 3u is u. So we never need to use the 3u again. We never need to use the 1/3. We already worked out what is 1/3 of the line, which is u.
So we have to use what we don't know to find from M to N then.
Correct. All right, so K to L now. So give me a triangle now that can take me to L. I'm at K at the moment. I need to get to L. Where
K
can I
to
go?
J and J to L.
I can go from K to where? J. Geneva says it, K, and somebody else too. K to J. So you're saying that I should go, give me a second here. You're saying that I can go from here to here. Sorry. So you're saying that I can go from here to here, and then I can go from here to here. Is that what you're saying?
Yeah, man.
All right, cool. That is correct. So K to L is going to be equal to K to J plus G to L. So K to J, J to L. Now the question is, what is K to J? What is K to J? Look at the diagram. What is K to J?
Negative 3u, sir.
That is correct. Negative 3u. Because in the initial stage, we were going this way from J to K. It said it up here, J to K. Wait there. It said J to K right here. But we are going the opposite direction, so it has to be the negative of that vector. So it's negative 3u plus JL. And
3v.
JL, positive 3v. Positive 3v. So from here to here is the line right here, 3v. And that's it. That's your answer. So the most challenging part of this, as you will encounter, is the 1/3. Like I said, all you have to do, guys, is just go back to fundamentals. Until you find a challenge with any mathematics, it's always because the challenge is from the root. It's from when it started. You never grasp any of the concept from when it started. And Daniela, we know you miss a whole heap of classes, right? So you missed the entire start of vectors. So fix up that.
Where's that, sir?
I'm just saying that you would have missed a lot of the vectors class. In fact, you missed the whole entire face-to-face vectors class. So that's why you're
Sorry, I understand vectors, but I doesn't understand the one with triangle.
going around the triangle. That's what you're saying? You don't understand how to go
Yeah.
around the triangle?
When the one that you taught at class, I did get that one, but me just not get this one.
Okay. All right.
Yeah.
It'll catch on though. All right. Last question says,
Yeah.
using your findings. So using your findings in BI. So using the findings that you got all your answers that you got down here. Using your findings in BI, out of the questions that you wrote down here, A, B, and C are the answers in BII, sorry. You're to deduce two geometric relationships between KL and MN. So what is the relationship that you can see between KL and MN? What relationship? Look at both of the answers now. I'm going to highlight them for you. Tell me, what can you observe? Look at the answer that we got for this, and look at the answer that we got for this.
That they're negative and positive, but respectfully.
That's an answer, but not the most accurate one.
Same expression.
Can't be the same. One has 3 in front of it. You're close. You're very close.
They're the same variable.
That's an answer, but you wouldn't get anything for that. Try again.
For MN,
One is 3 times the other.
That is correct. That is correct. KL, the matrix KL, sorry, not the matrix, pardon me. What am I talking about? Not the matrix KL, vector KL. So vector KL is actually equal to 3 times the vector MN. You can see the 3 that is in front of it. So you guys were fishing around the correct answer, you know. It's just that Daniela said a piece, Geneva said a piece, Javari said a piece, but then you guys were missing something. So you weren't realizing that. So, because for those of you who said the same variable, you can see it. Negative U plus V, negative U plus V, right? But nobody was mentioning anything about the 3 until the young lady just mentioned it a while ago. So KL is actually equal to 3 times, KL is actually 3 times MN. And this next relationship here, MN, and this next relationship is just the most common one, right? It's the most common one. The vectors are parallel. So basically what they are is that the vectors are parallel. If you notice that the arrows are going in the same direction, so we can say that the vector KL is parallel to MN, or the other way around. So you can say MN, let me just keep it KL same way. So KL, vector KL is parallel to, you can write out the words if you want to. Vector KL. So whenever you hear CXC ask you for relationships, especially under the topic vectors, whenever them ask you that, normally the answer is that they're collinear, parallel, or one vector is something times the other. So in this case here, the relationship is that KL is actually parallel to MN. And that's it. Okay? MN. So it seems like a tough question, and I'm not going to say it's not a tough question. It seems like a tough question, but as I said, you have to just wrap your mind around some of the basic concepts. And this is why I'm doing vectors and matrices all evening this evening, because you're going to see these principles being applied again. So far in this one question, you were exposed to biconditional statements, and you were exposed to triangle laws of vectors going around the triangle. So let us see if we can pick up on any of these things that we've seen so far. I'm not going to learn. Let us see if we can pick up on any of these things here in the next question. Right? Good. So now we're looking at this question now. Is another vectors and matrices question coming in a slightly different
excuse
form.
me, sir.
Yes, question.
I'm not sure if, sir, I don't know if my screen, but me can't see nothing, sir. Like it's small, really small.
You have to either jump out of the class and come back in, or I think it's just probably from your side, because this is, can you see it now? It's zoomed up.
Yes, sir.
It's zoomed up now. Can you see it?
Yeah.
Oh, so it's my fault then. All right. So I have to zoom out whenever I'm trying to get like I'm trying to grab my marker, my different colors, and then I zoom back in. So just bear with me there sometimes. All right. So let's look at another type of vectors and matrices question. You're going to see some similarities between what we need to do, but the questions are going to be structured a little different. So let's see here. Determine the inverse of the matrix. So in the last question, we would have been exposed to inverse, not true? let's go on our blank page down here and figure out what is inverse. What are the two components of finding the inverse of any matrix? Tell me what they are, guys.
Determinant and adjoint.
So we need the determinant.
And adjoint.
We need the adjoint. So you see, we're taking the information, Miss Paddyfoot. We're taking the information from the previous question, and we're going to apply that concept now to another question. So this is where you're learning transitional learning. Okay. So what's the formula for determinant? We discussed it earlier. It is AD.
So 1 over 6.
Determinant.
So we could have put 1.
Determinant.
So
Determinant.
AD plus BC.
AD
Or
minus
BC.
BC. Guys,
Yeah.
AD minus BC, not AD times BC.
Yes,
Okay.
sir. I just realized my mistake.
All right, gotcha. So AD minus BC. All right, Miss Paddyfoot, so make sure you take down that. That's the determinant formula. All right, good. All right, so now let me just grab the matrix just to make life easier. What's the matrix? Let me just grab it from now because I'm down here working on 3524. So I'm just put the matrix over here, 3524. And once you get a matrix, we already know that the matrix is in the form A, B, C, D. So in this case, then the determinant is going to be, since we label A as 3, and D is going to be 4, and B is 5, and C is 2. 3 4s is 12.
12 minus 10.
Yeah, which is 2. All right, so that's the determinant. Good. Now, we just discussed earlier what the adjoint is. And if you scroll back all the way up here to when we were discussing the adjoint, all the way up here, we mentioned something about switching and changing. That's all. Did I erase it or something? I did. I think I erased it. Yeah, man, I think I erased it. But yeah, I don't remember still. So the
Change the sign of B and C.
All right, good. So remember now, watch again. We switch the what? 3 and the 4. I would change the signs of the 5 and the 2. We switch the 3 and the 4. I would change the signs of the B and the 2. Write that down for those who are seeing this for the first time. When you're finding the adjoint, you switch the A and the D, and you change the signs of the B and the C. So in this case, then, our adjoint is going to be 3 and 4 switch, becomes 4, 3. Change the signs of the 5 and the 2, it becomes -5, -2. So now that I have the adjoint now, Daniela, your time now. Okay, did I jump the gun earlier? What is the inverse now? You were jumping the
1
gun
over 2 times that.
No, I want the formula first, guys. Remember, we are teach each other, you know.
Sir, the formula will be 1 over AD minus BC, which is, you already got the answer, so it will be 1 over 2.
All right, so it will be 1 over det. So what is the det? As Java
2
says, 1 over 2 times
time.
the adjoint over here.
So it will be 8.
8? Where you get 8 from?
2 times, 1 over 1, 4 over 2.
No, hold on. Put it down. 1 at a time, Daniel. You rush it. 1 over 2 times the adjoint. The adjoint is 4, -5, -2, 3. Then give me the answer now.
So
4 over
it
2.
will be 4 over 2.
Correct.
-5 over 2.
Correct.
-2 over 2.
Correct.
And +3 over 2.
Correct. Good. And then now, if there's anything to reduce it.
So
Right?
4 can be reduced and the 2 can be reduced.
Okay, so we can reduce those, and we're gonna get. You reduce this, you're gonna get what? 2.
2.
Leave the -5 over 2 alone. Leave the -5 2 over alone, because that can go down. This can reduce and becomes -1, and 3 over 2, leave that alone. Right? We don't use decimals in matrices. Okay? So that is how it is. Fraser, you were saying something about repeat. Repeat what? Finding what part? You said repeat, please, about finding that finding part. What part? He said the meaning. You have to explain yourself better, sir. Speak to your microphone. Come, I have a hard time understanding that text. It's a repeat about finding that part, the meaning. What are you referring to?
Sir, when you say when finding, you did say something about when finding something.
Oh, the adjoint you're talking about?
Yeah.
Okay. So when you're finding the adjoint, you switch the 3 and the 4. So the 3 and the 4, the line here, this line right here, so this line right here, those are the two numbers that you switch. And then for the 5 and the 2, those you change the signs. Don't switch them, you know. Change the signs. So these two numbers, you change signs. All right, cool. All right. Remember, when I'm not with you during the days or when you have your little free time or whatever, make sure so you're practicing stuff that's meaningful towards the back of the paper. So you have some little tutorials. You don't have to sit down and watch the entire 1 hour of the class. Fast forward up to the section that is important to what you're studying. Zane? So you have to deal with it coming up. We're pressed for time, you know. We're pressed for time. And we want to make sure so we understand anything at all that you need clarity on. You just fast forward up to that section and watch it. Okay? All right, lovely. All right, so that answers that question. Let's go back up here now. So we finish with that 2 marks. Now it says here that the transformation, and you might be asking, what is transformation doing at the back of the paper, sir? There was a time transformation used to come at the back of the paper. There was a time. Right? And sometimes it does come there, the concept of it. Anyways, let's write this out. The transformation M is the matrix 0A, B0. And it's saying here that it maps the point R onto T. So when you map a point onto another point, R is known as the object and I is known as the image. Let me reiterate that. Whenever you read a question and them say that something maps something onto something, the first something is the object and the second something is the image. So in this question it says that the transformation, this thing here, whatever it is, it did something to R. So this thing here did something to R, and when it did something to R, it made R become T. All right? So M maps to, oh, so sorry, it didn't, sorry, my apologies, guys. It didn't do something to R to make it become T. It did something to R and T. My sincerest apologies. Reading too fast. So let's read it again. It says here that the transformation here maps R and T. So what that means is that the matrix did something to R and it did something to T. And when it do something to R, it made R become R prime. And when it do something to T, it made T become T prime. Therefore, R is known as the object, R prime is known as the image. T is known as the object, T prime is known as the image. All right? So make sure you understand that sentence and what it's saying. Now look at what
Replay that as well.
The transformation M, whatever that is, we don't know, we don't care what it is, but what we know for sure is that whatever that matrix is, whether it be a reflection or a rotation or an enlargement or whatever it may be, it did something to R and T. It's almost, I put it this way, just to be comical. I throw water on you and you become wet. So I did something to you, and whatever I did to you, you become something else. So the matrix M maps R and T. R and T are separate points. And when it did something to R, it made R become R prime. And when it did something to T, it made T become T prime. Now, here is the numerical, whatever happened to it numerically. So look at what happened now. This matrix here, it did something to 7, 2. And after it did something to 7, 2, 7, 2 became what? 2, negative 7. And now you notice here that M again did something to what? T, which is negative 5, 4. And after doing something to negative 5, 4, it becomes 4, 5. Everybody clear on the explanation?
Rotation, that, sir.
We don't know, they never asked
One
you
more
that.
time, sir.
They never asked you that, Javari. We don't know. We have to answer what them ask us, I just want you to give me verification on in terms of explaining the sentence itself. Buckingham, is you again to explain?
No, sir. Soft.
No.
Okay. Who is it that want me to explain again?
Soft, sir. Soft.
Okay. One more time. I don't mind explaining, no. I don't mind. I just want to now listen, okay? All right. Come once more. We have a transformation here. And the transformation is 0, A, B, 0. Whatever that thing is, Javar was suggesting that it was a rotation. I don't know. They've never asked me that. Until them ask me, I'm not going to answer that. So the transformation M, it maps R and T. The and between the R and the T suggests that they are two distinct points. So R is a distinct point and T is a distinct point. Now, after M affected R, whatever was done to R made R become R prime. And whatever was done to T, it made T become T prime. Now, down here, so they're explaining to you what was the numerical outcome after M affected R. So we're told here that R was actually 7, 2. And because R was affected by M, or it was transformed by M, R was then mapped onto this thing right here. So therefore then, R, which was 7, 2, is now 2, negative 7. Similarly, M also affected T. And T was negative 5, 4. But after M affected it, it became 4, 5. Everybody clear on what that top part of the information is saying?
Yes, sir.
Yeah.
All right, good. Now let's get to work. Them say must determine the values of A and B. So how we are going to do this? How we are going to know what is A and B? Well, what we know is that whenever a transformation takes place, it means that multiplication is taking place. Whenever you see this word here, once you see this word here, transformation, majority of the time, 75% of the time, it's going to be a multiplication process. So you might ask me then, just in case you're thinking it or you're about to think it, sir, how are we going to know when it's not a multiplication process? Whenever they mention the word translation. Of the 4 transformations that you've been exposed to, of the 4, and what are the 4? Translation, reflection, rotation, and enlargement. Of the 4, all 3 of them, reflection, rotation, and enlargement, is a multiplication process. Translation is the only one where you add. All right? And there's no mention of any translation here, so we know we are going to multiply. So what's going to happen now? Watch now. We're going to take the matrix M. What is the matrix M? 0A, B0. So we're going to take 0A, B0, and we're going to multiply it by 7, 2. So why 7, 2? I'm just picking a point. I could pick R, I could pick T. Anyone when we do me, I'll get the answer same way. So I'm taking the matrix M and I'm going to multiply it by R. So M will affect R and make it become R prime. So that's going to be equal to R prime is 2, negative 7. So read it again now. The matrix M. So the matrix M is affected R and make R become R prime. And because this type of transformation is a multiplication process, we're just going to simply go row by column. Row by column. So go row by column. Yes.
It is 0270. Am I correct?
Come again?
0270.
I go work it out. 0
Okay.
times 7 is what? 0
0.
plus 8 times 2 is what?
2A.
2A. So that's the row by the column, not true? All right. We go row now again now and go down the column once more. B times 7. 7B.
7B.
And then now we end up with 0 times 2.
0.
0. And that is going to be equal to 2, negative 7. Let me just write it better. 0 plus 2A. I'm writing it lower, guys, so I can get more visual. 7B plus 0. Let me just erase this here. So that now is going to be affected. So after we do all of that multiplication there, it's going to be equal to 2, negative 7. All right. Now at the top now, we know so when you add 0 to anything,
I have a
we can see.
question.
All right, yeah, go ahead.
How did it become negative?
How did what become negative?
The 7B plus 0.
7B plus 0 becomes negative. What do you mean become negative?
I see negative 7 here.
They gave it to us right here, darling. They told us that when you multiply M times R, you get R prime. So they're the one that gave us the 2, negative 7.
Okay.
Yeah. All right, so we already know that when you add 0 to something, you can just ignore the 0. Basically, just ignore the 0 because 0 plus 0 minus anything is going to give you the same thing. So ignore the zeros. So basically what we have is 2A equals 2, and we have 7B equals negative 7. Two separate equations. So we have 2A equal 2, because the top must equal to the top, and 7B equals negative 7. And we solve them separately. So 2A equal 2, divide both sides by 2. What is A?
2. 1.
1. And 7B equals minus 7. What do we get for B?
Negative 1.
Negative 1. Those are your solutions. So A is 1 and B is negative 1. Yes.
So I get 1 for A.
I divided both sides by 2. So if you divide both sides by 2 here, they cancel, and then 2 over 2 is 1. But just cut the corners because I'm assuming that you guys know how to solve equations. All right, so that would be, yeah. So this was one of those type of questions back then that used to give students, back in my time, a lot of challenge. The interpretation. What does transformation mean? And what does it mean? When the question's structured like this here, if you're not exposed to it, you'll see it and you're probably not going to know what to do. This is why we're going through this excruciating marathon. That's what we call it. You're being exposed to a lot of questions of a lot of different structure and different type. All right, so you can get familiar with how these questions are asked. Okay, all right. So that takes care of that. Now, Javar, your turn. It says that we should we should describe fully the transformation M, and that are 3 marks, So we know it can't be a translation. We know it can't be a translation. You see, back in them time here when we went at the maths, this is 2011, guys. When we were doing maths them time here, we had to remember what these matrices were. You see them 0, 1, 1, 0, we had to remember what these things are. So look here now. We don't know say A how much already. We get A to be what? 1. So A is 1. And we just learned that B is what? -1. So you see, back when we were learning these matrices, like now when we hide it from you and don't tell you, we had to know when we see these numbers, we had to know what that matrix was. In our heads, we had to know what that matrix was. We had to know what it was. So this Jabari is actually a rotation, right? It's actually a rotation. And you're probably asking then, sir, how? So you know it, sir, but how am I going to know it if I see this on the exam? It's a matter of knowledge. That's all I can tell you. It's a matter of knowledge. So it's either you know it or you don't know it, or you guess it and get it right. Right? Now, what I want you to do for me, guys, go on your calculator for me, please. Follow this for me. Go on your calculator for me, please. And I want you to press the following buttons. All right, on your calculator. You're going to press Shift. That's the button to your top left. Press Shift. Press Cos and press 0 and tell me what you get.
I got 90.
90.
90. Do the same thing again now. Press Shift, Cos. Press Shift. Sorry. Press Shift and press negative sign for me, please. And then press 1. Press Shift, press negative sign and press 1 and press equal. What you get?
Sorry, repeat that.
90
Press
again,
Shift.
sir.
Press
It's
Shift.
90. So that means it rotates
Minus 90, sir.
Correct, minus 90. Yeah. So it rotates. You're asking Buckingham, what's it that book? That's one like Buckingham voice. You press Shift, you press negative sign, and then press 1 and close the bracket. You should get 90.
I got 180.
You can't get that. You press
Negative 1 bracket equals 180.
All right, hold on. Cos theta, negative sine theta. It is 90.
180, me get to, sir.
I know 180 though. I can't tell you that. I'm sure no 180 this. It is 90 though. But next time I show no for deal with it still properly. Because we don't want to waste time on this here. Because it's not that
So
important.
should we press cos inverse or just press cos?
Cos inverse. You have to press Shift and press Cos and press the 0. But anyways, it's not a big deal. It's rotation of the cons. I know, no, but that's just it's fine, guys.
Sir.
Yes.
Probably didn't think you say you must press cos when you find the -1 because a while ago I pressed cos -1 and I'm getting 180. But they never hear when I say press sine.
Well, probably that. But like I said, but that's stress it. We don't want to throw up the class. It's not a big deal. Just know it's a rotation of 90 degrees counterclockwise. All right? Yeah, man. Let's write that down, guys. Describe fully the transformation of M. It is so M describes a rotation of 90 degrees counterclockwise or anti-clockwise, as I say. So this may be just what like yes. Question again.
So how did you know it was 90 degrees?
Pardon me?
How did you know it was 90 degrees?
We just said it a while ago. You press Shift, you press Cos, and you press the number and the 90 come up.
So how do I know that I should use Shift Cos to
It's
find
just a
what
matter
it is?
of knowledge, like I said. That's what I'm saying. It's just one of those questions where it's a little bit deeper. I can't explain it right now on this class. So it might be just one of those questions where it's either you know it or you don't. And we're not going to have time to spend time and try study or if we get 3 marks, we can get these 3 marks elsewhere. So we have to just focus on some of the important things right now. Right now in this moment, because we're pressed for time. Okay? Everybody good with that?
Yes, sir.
Yes, sir.
All right.
Yes, sir.
Gucci.
All right, so it so write this sentence now. The sentence is M describes a rotation of 90 degrees counterclockwise. Yes, Richard, so you could say that it's the same thing as 270 degrees clockwise, you have to say though. You have to say clockwise though, not anti-clockwise. If you say 90 clock, sorry, if you say 90 anti-clock, you have to say 270 clockwise. All right, cool. All right, so get off of that. Like I said, it could, like I said, if you meet if, and it's a big if, the maths now is not maths then. If you book up on a question like this, remember that you have a bag that is filled with 40 waste points. It's not a good advice. Like I said, it's just I'm giving you advice based on the time frame that we have leading us to exam. You have a bag with 40 points that you can dash. Try to maybe say something and maybe get the full 3 marks, but you might have to throw these points in the bag. All right, it won't affect you. You're not going to fail because you don't answer the question. That cannot stop you from passing mathematics. So it's neither here nor there, and the price of rice now going to change. All right, so let's move on to something more important for now.
Sorry,
Yes.
what if I just plot the points on an imaginary graph and just look where each point is, like where it rotates to?
If you want to do that, that means you're probably sound very desperate for the 3 points. So if you want to go that far for the 3 points, then okay, no problem.
Okay.
So if you want to make a sketch of it, that's actually a brilliant idea. That's actually a really, really good idea. You could actually go ahead and plot the points, and then you can visualize if I turn it, turn, or I flip it, flip. Yeah, man, that's a good idea, Simara. A very good idea. All right, give me a second. I want to make sure that the chat is still on. It is fine. Okay. Lovely. All right, so we're going to go back to that. You remember that challenging question that we had earlier? And we had Miss Paddyfoot and a couple other person might have a challenge. Let us see if we can transfer that learning here now. All right. All right, so WXYV is a parallelogram right away. Right away, in the very first line, we get a clue to how we're going to start the problem. We get a clue. What do you guys remember about what do you remember or what do you know about a parallelogram? What's the most important thing you know about a parallelogram?
Sir, it's a four-sided shape.
It's a four-sided shape. All right, cool. And what the most important thing though?
The opposite sides are equal.
Be very specific, Richardson and Geneva. You say equal, but you don't say what is equal. Angle equal or what?
Sir, the parallel
sides.
sides.
The sides are equal. The opposite sides are equal. Is that what you guys are saying?
Yes, sir.
Okay. So in that one sentence alone, without reading any further, I know that this side will be equal to this side. And I also know that this side will also be equal to this side over here. So question now, if this side down here says A, what is this side up here?
A, sir.
All right, A again. So we already know we can start right down that if this side is A, up here saw A already. That's the first thing I want to do. As I read, I want to interpret. So up here so is A. Because down here says A, up there says A as well. And if over here says B, what can we say about over here?
Sir, the other side is also B.
All right, good, solid. All right, so the first line in the question, or in the information, gave us a clue that we need. All right, move on. It says the vector Vy. So Shamir, we can see this time now they gave us the arrowhead. So the arrowhead kind of tells us that we're moving from V to Y. But differently from that, still, them have the arrowhead on it already. Right there. So can you see the arrowhead right there? It's pointing towards Y.
Yes,
and
sir,
it's also here, it's pointing towards W. So even if they never put on this arrow thing over it like what they didn't do the last time, we can see it right here. All right, that good?
Yes.
Lovely. Now, this is the biconditional part. Now, you know that little one that we went into earlier with the 1/3, we get another different type of biconditional statement here. S. And you can see the S right here. S. They're telling us what S is. S is a point on WY. And you can see very clearly that S is on WY. See WY here. So S is on the line. But how is it on the line? It is on the line in such a way that from W to S, so from W to S, so from W to S, so from here to here, is, sorry, from here to here, compared to here, the ratio is 1 to 2. Now, how do we deal with a ratio? Anybody knows what's the fundamentals of the ratio? When we see a ratio, what do we do? What do we normally expect?
So we add the total part and then we is divider. Yeah. So it'll be 3 and then
Hold on, slow down. So 1 plus 2 is what? 3.
3.
So what does that 3 mean? That's the big question. That 3
That's the total
means that
part.
pardon me?
Is that the total of things that you have, I think?
Well, it's the amount of parts that the line has
The
been
line
divided.
W2Y is divided into 3 parts.
Right, that's what it means, right? So that means that from here to here is 1/3. And then we're not just put an imaginary line here. It's not there, but I'm going to put an imaginary line. From there to there is another third. So 1/3, 2/3, 3/3. All right, so watch this now. Move them blue lines here now. So using a different color now. From here to here is what? 1/3 of the entire line. And from here to here use a different color, give me a sec. And from here to here represent how much of the entire line? Bet you don't get it.
2/3.
2/3 of the entire line. We don't know what the entire line is yet, but yes, when we find it, we already find WS and SY. So we know that it's going to be, zoom it up for you here. So from W to S is going to be, sorry guys, my screen jumped off, give me a second. All right, good. So back here. So from W to S is going to be 1/3 of the entire line. Give me a second. Let me grab a pen. Right. Good. So from W to S is 1/3 of the entire line. And we don't know what the entire line be. So that means that we know said SY is going to be what? 2/3 of the entire line. And until we find the entire line, we don't know what to put in this bracket right here or here. So whenever you see me do this, guys, in the next questions that are coming up, right? What I'm doing is what I'm doing here is that I'm interpreting the biconditional statement. I'm trying to figure out what this biconditional statement is saying. That's why you see me use the colors, and those little stuff here. All right. So now that we get rid of the biconditional statement, now it's time to answer the question, which is the easy part. WY. May I please clean up my diagram or make it see? You know, all right, with the diagram have the colors and stuff. Should I let them stay?
Yes, sir.
Sorry.
Make them stay. Okay,
So,
all right. Yes, question.
so you say WY is divided into 3 parts, right?
Yes.
But I'm seeing W to S is 1/3 of the whole line, and then S to Y is 2/3 of the whole line. So where's the other part?
So what is 1/3? What is 1/3 plus 2/3?
3, but isn't it 3 parts? So
They're not treat that. Isn't that 3 out of 3?
But wouldn't you have 3 parts though? Why is it just 2 parts there?
Oh, me get what you say. Okay, the other part is gonna be like right here then. Since you're looking for it, right here, so. So it's 3 visual parts, right? Like that, the 2 blue. But we don't need to put this one here because it's going to divide up the 2 thirds. We don't want that part there, so.
Okay.
Yeah. But I get what you're saying though. Because I
What
told
if
you 3 parts.
if we try to find the midpoint to get the answer?
We don't need any midpoint. Then I mentioned not about midpoint, so nobody inject that in there, please.
Okay then.
Yeah, just work with them give you. Them say 1/3. So if you know 1/3, the other part of it's supposed to be 2/3. It's just that the 2/3 is 2 1/3 put together. So this part right here, so is 2/3 right here. Is really 2 1/3 put together to make one line. Okay. All right. So WY now. So again, Buckingham, you were saying something about not understanding triangles or vectors. Here's another opportunity again. So I'm trying to get Buckingham from W to Y, but I cannot go straight. I need to use a triangle that can take me from where I'm at to where I want to go. What triangle do you visualize on this diagram? I'm at W.
WXY.
No, but remember in our first place, no, analysis, we know this, you know. We never did know them there, so nobody go that direction there. Don't go that direction. We never know that because we analyze the question. Why we know that? Go the direction where they gave us the information here.
WV and then V to Y.
WY.
How you get W? A WY we want, you know. I heard the answer, guys. I heard the answer. I'm just analyzing. We are trying to get from W to Y. So don't you think that we need to go this direction, then go that direction? Is not an appropriate triangle?
Yes, sir.
Yeah. All right. So we're going to go so, and then we're going to go so. All right. Cool.
Minus
So
B
ready now.
plus A.
So look at the arrow now, Shamir. The arrow, as you can see, is pointing that direction. That's all. But we are forced to go in this direction here. So if going in that direction is B, going in the other direction is what?
Minus B.
All right, minus B. So let's write the formula first. WY is W to V plus V to Y. All right, so that means that WV is negative B and V to Y is?
Positive A,
Plus
sir.
A.
Positive A. Geneva, me I see you now. Geneva, I'm seeing you when you're talking, you know. And probably, you know, if you hear me acknowledge you, is because a lot of persons are texting, so. Once I see you and I see you mention a correct answer, I don't want anybody in the comments to think I'm not seeing what you're saying. So Javari, Richardson, Geneva, I'm seeing everything that you guys are saying, even if I don't acknowledge it, but I can't respond to everybody at the same time. All right, so that's it. That's the answer. Done. But them say they want the answer in terms of A and B. Our answer has A and B in it. So we're done. That's it. All right. So look now, Buckingham, how the biconditional statement come in. Simar, look here now. They might ask you for what? WS, not true? And remember that we had already analyzed that WS is what? 1/3 of the line. So you see how analyzing the question from the get-go just make it easier if you know, say, WS is 1/3 of WY. We don't establish that WS is 1/3 of the entire pink line. The purple part is 1/3 of the entire pink line. So we know that the pink line just work out to be negative B plus A. So the analysis now helps us to write down that it is 1/3 of the entire line, which is negative B plus A. Because we fix up that nice and neat now. You can leave it here so still in about. I don't like it so.
Run over that again, sir, please.
The purple part that I've shaded right there. From the onset, we did establish that it is 1/3 of the entire pink line. Remember that?
Yeah.
Good. The pink line is which letter? Which 2 letters make up the pink line?
1/3 and 2/3.
Which letters
Oh,
make
S.
pink line?
WS.
The pink line, the entire pink line. Which two letters?
WY?
WY, sir.
WY. Good. So what is WY? What we just find right there, so?
3.
WY what we just find right there, so?
1
Negative B plus A.
third.
Negative B plus A. So what is WS then? It's 1/3 of that. So it's 1/3 of the answer what we just get. So we're going? Come again. One more time. Do we all agree? Well, no, if you agree, because I want to tell me. I shouldn't even ask you that. But anyway, I'm going to ask you. It's a rhetorical question. Do you all agree that W to S is 1/3? Sorry, do you all agree that the purple indicator, the purple line there, is 1/3 of the pink one? Everybody agree with that?
Yes, sir.
Yeah,
Yes,
man.
sir.
Yes, sir.
Good. What two letters make up the pink line?
WY.
WY.
Good.
WY.
So the conclusion then is that WS, which is the purple line, is going to be 1/3 of the pink line, which is WY. So WS, what we are trying to find, yes, so is 1/3 of the pink line. So it is 1/3 of WY, which is basically 1/3 of the answer what we just get right there. So fixing up this nice and neat. Why this thing keep jumping off? Hold on. I mean, yeah, it's loading. So fixing up this nice and neat then. So fixing up this nice and neat, then we're gonna get negative 1/3 B. Hold on, guys. I don't know why my screen keeps shutting off. Give me a sec. Give me a sec. Keeps jumping off. Don't know why. If you jump off again, I'm gonna set my slide.
Sir, I don't know if the others are seeing it, but low bandit is coming up and then they say unstable network. So I don't know if it's mine or yours.
Oh, I think it's probably mine. All right, so if you jump off again, I'm gonna reset my device and come back. Okay, all right. So if you know, jump off it. So what is 1/3 of negative B then? It's going to be negative 1/3 B. 1/3 times the letter is 1/3 the letter, negative. And what is 1/3 times A? Positive 1/3 A. I'll leave it there, so. All right. If you leave it here, how much marks it worth? How much marks it worth? Hold on. We know so the first one is worth 1 point. The second one, no, the first one worth 2 points. And the two last one worth. All right. We know so this one worth 1 point. We know for sure. So this is probably worth 2 and this is probably worth 2. So because it worth 1, I can't say for certain if you don't simplify. I think you're going to get the 1 mark. If you left it at 1/3 open bracket minus B plus A, you'll get the answer right same way. I think so. I would give you the mark. I wouldn't be tripping about that. All right, SX now. So obviously, to get from S to X, we have to draw one line connecting them. Because there's no line from S to X, so we're going to draw our own line there. So from S to X.
S to W. Then W to X.
All right, so now I get have it, my G. So S to X now, what them say they want? They want we to write down in terms of A and B, S to X. So tell me again, my general, what you say S to X is?
S to W.
S to
And
W,
to
and then W to X. Everybody in agreement with the young man?
Yes, sir.
Yes, sir.
Yes, sir.
So S to X is S to W.
That'll be minus 1/3.
Hold on, take time with me, my G. S to W plus W to X. W to S. W to X, right? All right, now. Ball game time now. What is SW? Careful. Think before you answer. What is S to W?
Minus 1/3.
minus 1/3.
Hold on. Let me highlight something. So not talk foolishness. Hold on. What is SW? Think before you answer. What is SW?
So the negative 1/3 of the of WS.
1/3 of WS. Correct,
The
right?
answer that you got.
Yeah, but me circle the two answers them in green. So now you have to tell me the right answer we need. Look at the ones in green.
So
What is
that me just
SW? You're not giving the answer tomorrow. Try again.
it will be negative 1/3 of the answer in green.
No, close but not close enough. Try again. Remember say SW no. Look at it now. SW no is the inverse of WS. Remember that? So look
Sir,
at the
it's
one.
going to be positive.
Say it and stop. Coward. Are you coward, someone?
Sir, it's minus
Positive,
1/3 B
positive, sir.
plus
So it's
1/3.
positive then, sir.
Hold on. Miss Gentles, go ahead. Go ahead, Miss G, go on
It's
ahead. Let me hear you. Go ahead, Miss G, me not hear you.
I'm saying that it's minus 1/3 B plus 1/3 A.
You're close. You're close. Me just get
The
the clue, you know.
sir,
Sir,
the
me just say positive.
positive
Positive
B,
what?
1/3 B,
1/3
and
and then minus
negative 1/3 A.
Right, that's all right. That's all. Cause remember now, Miss Gentles, remember say SW, you know. SW, you know, are the inverse of WS. But watch your style. You don't already have WS already. So what the opposite of something there? Just like what they just said. It is going to be 1/3 B minus 1/3 A. Everything at the opposite. Because this was negative, you know. So because of the inverse, it becomes positive. And because this was positive, because of the inverse, it becomes negative. Catch you now, Miss G?
Yes, sir.
All right, good. All right, now. And what is WX now? Look at your diagram.
I don't understand how you get that.
All right. If I say to you from S,
Sir, wait, explain it showing the triangle. I want to see the triangle when you explain it.
or the triangle, okay. So the triangle here, the arrow is going that way.
So I
From the
want to see
onset.
both. I want to see both the answer and the triangle. Yes.
And that you want to see?
Yeah.
All right, so let me zoom up on the triangle first. Look, here. WS was already going that way. And we already established that WS was this answer down here in green, right? That's all. That was WS. Do you agree with that?
I
Yes.
think moving back and forth from the triangle to the question is confusing.
All right, so let me
Yes.
stay up on the triangle first. WS was already going that direction. Do we agree? Talk to me now.
Yes, sir.
Yes,
Good.
sir.
But we are going this way. Talk to me. So we are going the opposite direction of the answer that we got for that. Now, I'm going to go back down here now. What was the answer for WS? Negative 1/3 B plus 1A plus 1/3 A. So opposite that now. Talk to me now. Negative.
Yes, sir. I get it now.
Okay, Shamir, you get it?
Yeah, I think so.
Right. Because remember say inverse, you know. All we have to do is change the signs, you know. So if we already know that WS is this thing down here where we established from D1 down here. But we are going SW at the opposite. The opposite of negative 1/3 B is positive 1/3 B. And the opposite of positive 1/3 A is negative 1/3 A. All right. What is WX now? Look at the diagram now. Remember, say all our analysis from before, you know. All our analysis gave us the answer. We analyzed the question from earlier. So what is WX?
A.
Very good. Wx is A. Now you can't leave it there. It not simplify. It's not simplified. So something have to go add to something. What can we add to what? Something have a breakdown. You probably only, if you leave it there, you're gonna get 1 mark out of the 2. So we have 1/3 B minus 1/3 A plus A, which is basically 1A. LCM right here, so not true. Which is 3. No, sir, I'm not doing LCM. I'm not feel so. No. Come on. So if you take 1/3 from a whole, how much is left? 1/3 from a whole, 2/3 is left. Yeah. We think we equip like that. If you want, go ahead and find LCM, you can, but I don't think it's totally necessary. So 1/3 B, and then we know so we got a plus 2/3 A. And that's it. That's the answer. If you want to go ahead and find LCM, you can do all of that extra stuff. Negative 1/3. We find about the LCM. And the number in front of A is 1. What's the LCM? 3. 3 into 3.
1.
And 1 into 3.
3.
Good. What is negative 1 times 1? Negative 1.
1. 1.
And what is 3 times 1? 3. So what is negative 1 plus 3?
2.
Over 3. 2/3. That's how we get the 2/3. So if you want to do this, you can do it if you want to. But I don't think it's necessary. Because if you're taking away 1/3 from a whole, I have 2/3 left. So that is how we get the 2/3 there. And if you're gonna ask me why did I add them together, because they are like terms. Them 2 here, oops. So them 2 here. So these 2, oh my, where them gone? So these 2 here are like terms. That's why I add them together to get our answer. All right, so that takes care of that. Now, this is the part now that students don't really like. The collinear part. So this is one of those challenging questions. Like I said, it's one of those questions where you might have to throw it in your bag. But I don't want to tell you guys on this recording, That means that a person are going to be hearing it say, I'm telling you to give away points. I'm going to show you how to do it. But if you're in the exam, don't beat up your gum about trying to get the 3 points. Leave it, and we'll learn it in our next life. Because you're in the exam is worth 15 points. You don't get 12 out of it already. The 3 points cannot make you fail the exam. All right? So here we must know. R is the midpoint of WV. Let's look for that now. R is the midpoint of WV. It's WV here. So you're saying that R is in the middle of that line. Let us find the middle of that line now.
Can you keep the diagram and the question in the same font?
In the same size?
Yeah.
Okay. Okay.
Thank you.
All right. So is it because I have to kind of zoom up on the ear more, you focus on, that's why I keep doing the screen like that. If I do it like this, I won't be able to toggle in between the spaces. So you have to bear with me, Shamir.
I think we can zoom with this.
Oh, you can zoom?
Yeah, we can zoom.
All right. So yeah, but my life I got difficult now because my screen's so small I can't get into the crevice on the corner. Because if I don't do this, you see, I can't really do this right here. It's gonna make life difficult for me. So that is R. Yeah. So R is in the middle right here. All right. And you're saying that we should what? Prove that R, S, and X. So prove that R, S, and X. Let's draw a line from R to S to X. So RSX. So prove that R, S, and X are collinear. What do you think collinear means? Based on the green line.
They're in a straight line.
They're on a straight line. You must prove that R, S, and X are on a straight line. So collinear means that 3 points are on a straight line. But how are you going to prove this now, though, God? Let me show you how you do this now. So in order for you to understand this thoroughly, I'm going to use a much clearer diagram so we don't mess up while going up here. So, okay? I'm going to use down here to describe this for you. Okay? All right. So look at this. I'm going to use you guys as examples, right? All right. So this is Javari right here. Hold on. So this is Javari right here. This is Shamir right here. I'm going to put Shamir, Javari. This is Buckingham right here. So Javier.
Sir, so why my head off is so big? Sir, I don't want that big head.
Oh my God. All right. So that is Javari at the top, right? And this is Shamir down here. And this is Buckingham right here. All right. And then we're going to put somebody else. Let us use
Samari, sir. Samari.
Simara, right? Let us use Simara right here.
Because I'm wondering.
All right. So look at this now, guys, just to demonstrate from a comical point of view. The diagram will draw perfectly, but if you can agree that
No, in the job perfectly.
that's fine. Go stay on point, guys. Focus. We're trying to prove we're trying to let you understand what is collinear. So we can agree that these 3 persons are in a straight line. But Javar is all the way up here. So listen good now. If we are going to prove that Shamir, Buckingham, and Simara are standing straight in a straight line from each other, watch what go on now. We have to go prove say this length plus this length is equal to. All right, so I'm going to put this on. Hold on, give me a second. Let me put it together properly. To prove that these 3 people are in a straight line, we have to prove that this length here, all of this length here, is exactly the same as this length plus that length. And that we have to prove. Let me say that again. If we are going to prove that Shamir, Buckingham, and Simara are standing in a straight line, we have to prove that all of the distance from here to here is the exact same distance as from here to here plus here to here. Now, to do that, we have to find this distance piece by piece. So we have to find this distance right here, so add it back to this distance right here. So in order for us to find all of this distance right here, we have to find this distance here and this distance here. Anyhow, we find this distance right here, so and then we add this one and this one and we get the same thing, then we can prove that the lines are straight. That's I guess this is from an intuitive point of view of what I'm trying to say. So I'm going to erase this not so attractive diagram from the screen. I'm going to bring back that concept to the main diagram here. Bear with me now, guys. Focus. Focus. If you want us to ignore the 3 points, and moved on, we can do that. But so look what I go on now. We are trying to prove that this distance here to this distance here is the same thing as this distance plus that distance. On a good there, sir? So we are trying to prove that the green distance is exactly the same as the 2 blue distance. On a good?
Yes, sir.
That is the proof we are trying to make. So we are trying to prove that the green line is the same measurement as the 2 blue lines added together.
So, sir.
Yeah.
Could I have which direction? Or go down or up?
R. No man, I saw it go the vector go remember say R, S, and X, So I saw it go. See the arrow this already. See there.
Alright, say I have R plus W to
W
R
plus
plus
X.
A.
R to W plus W to X.
Yeah.
Right. That have a proof that Rx is the same thing as that. But how can we find Rx? Give me the break up Rx into smaller portions, please. Oh, sorry. Let me write it down first. So we're trying to prove here that Rx, hold on. Oops. So we're trying to prove that Rx is equal to Rw plus Wx. Not true? How we don't say Rw is what? What is Rw? Remember say B is in the middle, Remember say R is in the midpoint, So what is Rw?
A half R.
It can't be half R. What's the magnitude of the line? Me hear the answer a while ago. Who said it?
1/3.
1/3? You sure about R is in the middle?
Oh, so it's midpoint.
So it is what?
Half times B.
Correct, half B. So Rw is half B. All right. And what is Wx?
A, sir.
A. Good. So what we are trying to do now, people, right? We are going to prove that we can find Rx. So this is Rx, Rx is actually equal to this. So we have to try to find Rx another way. That's what I'm trying to say. Anyhow we can find Rx another way, we're good to go. So look at the diagram now. Give me another way how we can find Rx. Break it up in pieces. Look at the diagram that I did with Shamir and Buckingham and Timara. Break it up in pieces. Talk to me.
Sir.
Yeah.
You want one different direction or you want the smaller pieces on the same line?
Smaller pieces on the same line, Safani, right?
So would it be RS plus XS?
Brilliant. So RS, so RX now, we can find RX another way now. RX are actually equal to RS plus SX. You see, anyhow, we work out this here, and we get this, prove it. Because that's the only way it can be straight. They have to be the same thing. So, let's do that then. What is RS? Give me a way how we can find RS now. Focus.
R to W, W to S.
Very good, sir. Again, not going good enough. I can focus. So RS is actually equal to R to W plus W to S. What is R to W?
Half times B.
Half B, very good, half B.
Gonna have WS already.
my G, right there so. We have WS long time from up here so. See the blue line, see the blue arrow we point? We have WS already. So take the answer there now and carry it, go down there so. So we're going to end up with now. We're going to end up with minus 1/3 minus 1/3 B plus 1/3 A. Not true? Let's simplify this now. What and what is the like? What are the like terms?
B.
Half B and negative 1/3 B, not true?
Yeah.
So find the LCM of that now. What's the LCM?
6.
2 into 6.
8 times 1.
2 into 6.
3 times.
3 times B or what?
3B.
Minus 3 into 6.
2 times 2B.
So you have 2B. Not true? Alright, so when you break up that now and make it easier now, you're going to end up with 3B minus 2B. A B this is now 26. B, 3B. 3B minus 2B is what?
1B.
So basically 1 6 over B. 1 6B. Write it better.
1B over 6.
Alright, so 1 6
B over 6.
Yeah, 1 6 B. That's let's say 1 6 B. Alright? Plus 1/3 A. So now we have RS, not true. Put that now on like a box, right? So we have RS. So the answer then now, we need to put right so. So go put 1 6 B right so. 1 6 B plus 1/3 A. Hold on, let me just make it smaller. 1 6 B plus 1/3 A. Alright, so this part here are RS. Alright, what is SX? We never have it from earlier, obviously.
Yes, sir.
SX our. SX that's something.
1/3 B.
No, we did break it down simpler, man.
1/3 B plus
2/3 A. So 1/3 B. So that's plus 1/3 B plus 2/3 A. Alright, now all we have to do now, people. Let me just don't know why this looks like this.
Yeah, go group them now, sir.
Yeah. Well, let me just erase this here, right? So that's what plus 1/3 B. I jump off again, guys. Give me a minute.
Sir, keep your word. You say you're going to restart the device or restart the device.
After me can't bother with that. It'll go on with itself. It'll go on. Toggle. It's okay. You'll survive. Mm-hmm. 1/3 B plus 2/3 A. On third, let me see here. All right, good. So plus 1/3 B, 1/3 B plus 2/3 A, 1/3 B plus 2/3 A. All right, so as Java already said, now we got group-like terms. So group-like terms, now if we group-like terms and break it down and we get back this here, we have proven our point. So we're going to have 1 6 B plus 1/3 B plus 1/3 A plus 2/3 A. All right, we're going to find the LCM for this now. What's the LCM of 6 and 3?
6.
6 into 6? 1
1.
times
One time.
B is B, right? And 3 into 6.
2B.
2 times
2 times B plus, when you add 1/3 to 2/3, where you get?
4/3.
How will you say? What is 1/3 plus 2/3, miss?
3/3.
You get 3 on 3,
3/3.
so that equal
3/3
to
is what?
1.
Which is basically equal to
1.
1A, not true? Alright, so what is B plus 2B?
3B.
3B.
3B
3B
over
squared.
6. 3B squared. Add your add, miss. B plus 2B is 3B. So 3B over 6 plus A. Break down 3B over 6.
3
3 into
into itself.
itself, 1 time. 3 into 6, 2.
1/3. 1
So
over 3.
it's 1 over 2, man. Not 1 over 3. 1
Sorry.
over 2.
Sorry.
1 over 2B plus what? A. Which is the same thing as what is up here. There. Now, let me say something to you, right? Because I know what you guys are thinking. You're like, oh, no, sir. Me not go through all of that for 3 marks. Me agree with you. I agree with you. When I got my distinction and I saw this question on my paper, me say good night and goodbye. And I got an AA profile. So as much as it sounds complicated and it looks difficult, and it is, right? Because I understand what you guys may be looking at and seeing from your point of view, because I was at your stage one time before me they understand this here. So these 3 points here, if you think you're gonna have to put yourself through that duress just to get that 3 points, me guarantee you can get 3 times these 3 points in one other question. But it's my duty as the teacher to teach you how to get to the answer. So you can make a decision now that if you see a collinear question, don't waste not even 5 minutes on it if you don't know exactly what you're doing. Use the time to go get points elsewhere. All right? Yeah, man. So that's it. So this to me is the most challenging part of vectors. This to me is the most challenging part of vectors. And there may be other ways to do it, you know. This is just the way I learned it years ago. And I've never deviated from it. All right, so that is it. Yes.
Which year we reach?
Which year? Me not know. Me just a work question. Me not know which year. I think at 2013 or 2014 is one of them. Yeah, man. So Galia says she you girls when I chat them, I say, what them say? One says she a dash it away. All right. And Galia say, yeah, man, for sure. All right, that's no problem. But that is it. But you see them 3 questions that we wrote so far, people, I've exposed you to almost everything. But the foot say I totally shut. Yeah, man, it rough. I'm not telling lie, it rough. It rough. Shamir, what do you think? What do you think, Shamir?
May think may I go get the 3 marks somewhere else.
Smart. I got the 3 marks. I got the 3 marks somewhere else as well. And I got an AAA profile. And my maths here was tough. So,
sir, we can
yeah.
live for Christian and still get one AA profile.
What do you mean? I say,
Right.
out of my 10 questions that I did, you know, I left out 4 entire questions. 4 complete questions I left out and I get AA profile.
Blank, sir. Nothing.
Blank. I could not listen. I never understood nothing about functions and relations. I had absolutely no idea what is translation. It's like when you can tell me translation, reflection, rotation. Me don't know about that. I never know nothing about moving right along here. I don't know more about this thing than me than when I was actually at your level. All right. So now, after them 3 bombshell questions, now we have enough tool in the bag that can help us to gain at least a minimum of 8 out of 12 points on the exam. Because now what you're going to be seeing is an application of everything we learn. Let's go. So we're at 2014 now. All right. How much time we have left? 1 hour? We're stopping at 9:30 or we're stopping at 10 o'clock? What do we do? What do we decide?
9 o'clock, sir.
Sir, 10.
Tomorrow
10
nobody's
o'clock,
talking to you.
sir.
Nobody's
10
talking to you.
o'clock.
10.
Okay. Tomorrow nobody's talking to you.
Sir, 10.
10. Let's go. The points A, B, and C have positions OA 62, OB is 3, 4, and OC is 12, negative 2, respectively. Expressing the form XY, that means they want the answer to be written downwards like that. So whatever answer you're going to give them, make sure say it written downwards like that, the vector BA. Now, anybody remember how to find the coordinates of a vector? I gave you a shortcut. Because you're not on the graph now, so you can't go triangulars or vectors. It's I gave you a method where you see do something and then subtract.
A to B.
That the one that we just do it equal to.
Remember, see the band graph, so you can't use triangulars or vectors for this one.
So if you find x, y, right?
No, XY is not X here, try to find our Y now. Your answer should be written in the form of X and Y. Geneva say A minus B. Richard, yes. Check the comments, guys. You're correct, people. So whenever you're finding the coordinate of a vector, turn the vector backwards and subtract. So BA is actually equal to A minus B. So BA is actually equal to A minus B. Now, I think earlier I said that you can't use triangulars or vectors. The reason why I said that, because obviously other persons are going to be watching this video, right? The reason why I said that is simply because we're not seeing the graph. And it doesn't make any sense, Simara, that you make a sketch and go plot it just to see the triangle. That's a waste of time. It's only 2 marks. But if that you have to forget your 2 marks, do as you must. But for now, BA is equal to A minus B. Now look up. What is A? Look up here. So what is A?
6,
A
2.
is 6/2.
Hello, top about 6/2, miss. It's 6/2.
6/2.
You see no over there, sir? And what is B?
So we can see.
What is B?
3, 4.
3, 4. Very good. And we already know how we subtract matrices. First with first, second with second. Subtract for me, please. What is 6 minus 3?
3.
3.
And
what is 2 minus 4?
2.
-2.
And that's your answer. So the answer is in the form XY here. XY. X and Y. Here, so. Okay, good. All right. What would you say is BC now?
C minus B.
Say it again.
C minus B.
So
Correct.
B wouldn't be B times C.
No, we just do it a while ago, Buckingham. Turn the vector backwards and subtract. Correct, Smara. Me hear you. Me hear you. We just do it a while ago, miss. Enter you
Yes,
find
I'm
the code.
confused because we miss 2 letters beside each other.
You turn it backwards and subtract. That's the rule.
Alright, turn it backward and subtract.
That's correct.
That's
so
weird.
BC is C minus B. So C minus B. Okay? All right. What is C now? Sorry, I can't see it.
-2. So.
12, -2. All right. And what is B?
3 and 4.
3, 4. Subtract those 2 now. What we get?
9 negative 6.
9 -6. Good. That's the answer. So 4 easy marks there, so quick and fast. Remember, guys, you might just see this on the exam. Whenever you see a vector and there's no graph, turn the vector backwards and subtract. Turn the vectors backwards and subtract. Okay? All right. Now, you remember that question with them asked you earlier? Let me zoom back. Up here, sir. Remember when them did ask you something about one relationship? Remember I'm telling you, you see the first 3 questions about work are almost, you know. Somehow we have 50 caliber. Somehow we have one small gun, one pop. But so far after the butteration, we just go through with them 3 questions here, you're going to consistently see questions coming back. Remember when we had this question when them said deduce 2 geometric relationship, and I told you what the common geometric relationships were? Anybody remember what I told you what the common geometric relationships are?
Parallel are
Yeah.
3 times more.
No, alright, so you're not gonna say
Yeah,
3.
yeah.
You're not gonna say 3. You're going to say one vector is something times the other. You're gonna figure out what that something is. And then I gave you another word. See it right also. What is that? What does that symbol mean?
Parallel. Parallel.
Parallel. Good. So anytime,
I think you said
Shamir.
collinear as well.
Collinear was one of them as well. Good. Right? But collinear is usually seen when you actually have the graph. You can know when something is parallel even if you don't have the graph. Alright, so we say that. So there are 3 potential geometric relationships that accompanies vectors. One vector might be something times the other vector. 2, one vector may be parallel to the other vector. 3, one vector or vectors may be collinear. So anytime Csec asks about geometric relationships, are always one of them 3 there. If it's not all 3, it's 2 of the 3 or 1 of the 3. All right, so let's go back down here now and check and see if you can tell me which one you think it is. Now they're asking to state one geometric relationship between BA. So let me just highlight it. Give me a second. Hold on. Let me just get one highlighter for you so you see where I'm going. So you're going to look at the numbers now. Look at the numbers you have to look for now. What is the relationship between BA? Sorry. BA and
3 times the
BA and BC. That one here. Look at the
Okay.
vectors now and tell me what is happening. Look at the
BC
numbers.
is 3 times BA.
BC is 3 times BA, correct? And whenever you have a vector that is something times the other one, Shamir, it is also parallel. There's a high probability that it is also parallel.
Okay.
All right, so pick any one of those that you want to write. Right, so you can write like what Javari just said. You can say that the answer to this question would be simply that BC, hold on there. All right, so you can write that BC is actually 3 times BA. Oh, and don't forget the arrowheads, please. Left off the arrowhead, you get joke. If you don't put on the arrowhead, it's wrong. Well, if I'm me, I mark your paper and I don't see that, me, I mark it wrong. That's me. Okay, that's a me. The arrowhead has to be there. Because if you say BC, you're not saying it's a vector, you're saying it's a line segment. And there's no line segment there. Because number one, they gave you an arrowhead on BC. So why you eat the arrowhead? And I write down BC and want to get full marks. No, can't work. So the answer to this question is going to be 1. You can say BC is actually, so vector BC is actually equal to 3 times vector BA. See? Or, Shamir, you can just say that BC is parallel to BA. Both of those answers suffices to get you 1 mark.
Okay.
All right. Now, Samara, at your time now. Draw a sketch to show the relative positions of A, B, and C. Yeah, can you love draw a graph? So come now. You're going to draw one
I
graph
don't know
now.
what to do.
Yeah, but you were suggesting it earlier, right? Okay.
That's a question.
Yeah, all of a sudden you don't know what to do. Okay. All right. Anyways, so that means when we were doing, at the time when this paper was being done, we never used to get a booklet to write in, guys. That's why you're not seeing any empty pages. We used to have a separate booklet to write our answers inside the booklet at the time when we were doing maths, around 2014. So we're gonna have to do our sketch here. Nowadays, you get a graph inside of the booklet. So here now, all right, make a sketch of it. So now we're going to number our axes. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. I don't know how far I'm going. But there's a number stuff. 1, 2, 3, 4, 5, and then 1, 2. This is the farthest we can go. Right? If we need more, we put on more line. All right. Okay, lovely. So now, what was the first coordinate that we had up here? 6, 2, and 3, 4. 6, 2 meaning what, guys? 6, 2 meaning what? Which direction do I go?
X to the right.
And then 2 up?
Yeah.
Right.
So we're going to go this direction. So you're saying that we should go what now? 1, 2, 3, 4, 5, 6, up to somewhere, yes, sir? That you say?
Yeah.
Yes, sir.
Okay, so I'm going to put my point out, yes, sir. So somewhere out, yes, sir. Not accurate still, but you get it. And then what we're going to do now is that we're going to draw a straight line from here to here. That not draw good, my God. That like something somewhere would I do. All right, good. Or something that Jolly would do. All right, that is OA. Put on the arrowhead. Next one now is what? 3, 4. 3, 4. Okay, 3, 4. 3, 4 is what? Which direction? Talk to me.
3 to the right, 4 up.
So you're saying 1, 2, 3, and then 1, 2, 3, 4. Some up, yes, sir?
Yes, sir.
3 to the right, 4 up. So now we'll go here and here. All right. So somewhere there, so you're going to have your graph. And then you draw one line from here to here. It's supposed to be, it really supposed to be in the corner, guys, like in the center, yes, sir. So when you're drawing yours, you're going to draw it more accurate than mine. Because I'm not on the, like the thing that is on Zoom. We have a whiteboard. I'm not using a whiteboard. I'm actually using the past paper. So we don't have an actual accuracy. And this is the what? B now. And then C now is 12, -2. My box cover. I run out of space, guys.
So if you're going to make it weird, just estimate it.
Yeah, that makes it. But you won't do that on the exam. I don't estimate it because I'm teaching now. But on the you're supposed to have your 12 points go out. So 1, 2, 3, 4, 5, 6. And make up some points. 7, 8, 9, 10, 10, 11, 12. Just one line come back out here, so. So this is 12, -2. -2 is down, right? So 12, -2. So across from here and down here. Okay. So somewhere right here, so. Let me just use my arrow and draw a line from here to here. There. Beautiful. And those are my 3 vectors. That needs to be done. How is on? So you guys could manage this particular part. If you couldn't manage it, you can manage it now.
Yes, sir.
It's party food, so you stay.
Bits, a bit.
A bit. Wait, yes. Question, by the way. Have you been taught vectors? I don't know, first of all.
Not really. Not
so
really.
You understand why you're struggling then? You understand why it might be a struggle for you?
Yeah.
Okay. Because once you learn it, the reason why these guys, you hear them talking like this, is because me and them beat them to sickness with this. So that's the reason why they are able to talk like that, because we've spent a lot of time on vectors.
Okay, I understand.
All right, but just want to know, so you know, blame the maths and I say the maths hard. Is the knowledge that's not there as yet. All right?
Right.
All right, so good. So notice what them do now. Them put the vectors in front. Notice the 3 questions that we did so far is always matrices and vectors. Matrices and vectors. Matrices and vectors. Look at them do now. Them put vectors, then them put what? Matrices. All right. Calculate the values of A and B such that blah, blah, blah. When 2 brackets join together, what does that mean?
Multiply
And when we are multiply, where we go? We go row
by column.
By column.
Column.
All right. Remember, so we do that 3 times already, you know. Row by column. So when you see 2 matrices joined together like that, it means row by column. If you notice that they didn't even tell you to multiply, you have to know that you have to multiply. They only say calculate the values of A and B. But you know, say when 2 matrices joined together, it has to be row by column. All right, so somebody take a quick screenshot of this so that when I move my screen, I can just write down the numbers. Come on, but I'm telling you, by the time I finish with the know, by the time I'm done with the know, let me say, it's by Thursday, everybody done make up their mind what they're going to be doing at the back of the paper. May I tell you that? After tomorrow and after Thursday, and if I feel a vibe or not work with me, I jump on but the thing on Friday night. We just left Monday and just come back home. We prefer spend time with it now, waste time on Monday.
Sir, I'm screenshotty.
Okay, good. So if me feel a vibe and I give me energy and me ask an unnecessary forward back, come do 1 2 hours, me come again Friday night, come do the next 2 hours, and then I have face-to-face marathon, which is the last face-to-face marathon where we're going to be working a specimen past paper, and then Sunday when we're working the 2026 on a well arm up. On a well arm up for CXC, me I tell you that. And I ask her, tell me I tell you now. Not care what they throw at you. It's either in the moment the nerves get the best of you or you forget what you learn. But anyhow you're not nervous or anyhow you're not settled, if you're settled, are you not nervous? A dead bird then be. Dead bird.
Sir.
All right, let's go. Yes, Samara.
So Saturday class free.
All the classes are free, miss. What are you talking about?
Saturday's class free.
Pardon me?
The class free?
No, you're not easy. You're out of order.
Sir, you just said all the class free.
The class was not being recorded when I said that. So okay, let's move on.
So yes, you said free.
Moving right along. Let's go. Who said them screenshot the question? Run the numbers then for me now.
Alright, so Samari, look for your phone, we just send it to you.
Numbers, no guys, come on, man.
So
-4.
Hold on, one at a time, guys. Samantha, go on.
You have A, -4. 1, B.
A, -4. 1B.
Close the bracket. Next bracket now. 2, 4. 1, -3. 2, 0.
Equal
0,
2, 0.
2.
Okay.
And then 0, 2.
So go row by column this blow away now. Come in.
Row.
It's a -4.
Huh?
It's a -4, sir. And a -3 and
This is a -4?
Yeah.
Okay. Make sure you send it right. Hello. I'm not just not blow away now. Hold on. Just no. A, -4, 1B. And then 2, -4, 1, -3. Okay, all right, cool.
Yes, sir, it's correct.
All right, good. Row by column. Talk to me. Me not talk now. Me tired now, man. I'm not tell me if you multiply by whatever now. Come, tired.
2A plus.
Hey, talk. No, don't give me the answer. Say it out of your mouth like that times that, and then give me the answer.
A times 2.
Which is what?
2A.
All right, plus.
-4 times 1.
Is -4. All right, cool. Next column now. Hold on, wait. Let me draw down the line. Go on now.
A times
-4. That you say? Is that what you said?
Yes, sir.
Okay, -4A.
And -4 times -.
And then plus that now to -4 times -3, which is+12. All right, now we're done with that now. We're going to move to a new row now. So new row now. and we're gonna swing back down the first column again. Talk to me, which numbers now?
1 times 2.
Which is 2 plus
B times 1.
Which is B. Alright. Final column now.
1 times negative 4.
Which is negative 4 plus
B times negative 3.
Which is negative 3B.
Negative 3B.
Alright, good. So you like that, you just make that equal to 2002. Alright, now, big question coming up. How many, listen first before you answer, on the love jump gun, especially Samara. How many entries are in the first bracket?
4.
4 entries, not true. So just for some of you who is thinking it's 8, remember that 2a minus 4 is joined together. They're not separate. So nobody gonna say 0, 1, 2, 3, 4, 5, 6, 7, 8. Incorrect. It's not 8 terms. The 2a minus 4, they are together. So this is 1 term, 2 term, 3 term, 4 term. And if you have 4 term over on the left, and you end up having what? 4 term over here on the right, then every term is equal. So so basically we have equal matrices. So we're gonna have this term equal to that one. So we're gonna have 2a minus 4 must equal 2. How we solve that? Equal 0, sorry. How do we
Bring
solve
over
it?
the negative 4. It's gonna be positive. Then
So
I got to
2a
divide by
equals
2.
4, and then divide both sides by 2. We get easily a is equal to what? 2. Not true?
Sir,
Yes.
Sir, backtrack, please.
so if you say
Backtrack.
2a minus 4 is equal to 2, why you have 2a minus 4 equal to 0?
Oh, that's not true. Jabari, she catch you. She catch you. She
Are
catch you,
you say
Jabari.
are you right the thing wrong?
And now you work out the thing wrong. Ja. You work out the thing wrong. So 2a minus 4. She catch you, man. So she catch you. So 2a minus 4 equal 2. Alright, so already know. So we'll carry this over here.
6 divided by 2, same way.
See 2a equal 2 plus 4. 2a equals 6. And then just a I got equal to 6 over 2. A I got equal to 3. Alright, good job, Samara. Spot our mistake. And then now we're gonna make the next bracket now. It no matter anyone, it doesn't matter. We can make that easy one, that easy one right as well. Yeah, man, this easy one. Anyone you doing, you can use this one if you want to. Or you can use the easy one right as well. So we end up now with 2 plus b equals 0. So carry over that. B I got equal to negative 2. If you use the other brackets as well, other terms, you're gonna get the same answer. So these are your solutions here and here. Alright? Good.
Sir,
Yes.
they just want 2 solutions from both sides.
In a matter, them just find A and B. Them just find A and B. So for me find A and find B, me gonna road.
Okay.
Right. Alright. Now, a word here that we've been drilling for the past week, hence or otherwise. So maybe I have one other method. Hence or otherwise, write down the inverse of this thing. So how do we find inverse? What are the components of finding the inverse of that thing?
Determinant and the adjoint.
Determinant and the adjoint, not true? So say hence or otherwise, find the determinant. Let me see, 2, negative 4, 1, negative 3. So let me see, hold on, give me a second. 2, negative 4, 1, negative 3. Right. So we need the inverse of this thing. In a second, guys. So 2, -4, 1, -3. That's the matrix, right? So that equals AD minus BC. A is 2 times -3 plus B is negative. When we get plus from, what's here?
Minus, my boss.
My God. Jaja, respect. I think so untidy, brother. So AD are going to be 2 times -3 minus -4 times 1. So 2 times -3 is -6. Negative by negative is positive. 4 times 1 is 4. End up with -2. All right? Now what's the adjoint now? That's what them say otherwise, you know. Because me sure there's a shorter way to do this. But it's because they give me the option of otherwise, me not business. Me I take my time and do my thing. Switch up that now. -3 and 2. Right? And then we change the signs of what? So switch up -3 and 2.
+4, -1.
and
+4 and -1. That's true. So therefore, the inverse is going to be 1 over -2 times -3 +4 -1 +2. And what's the shortcut for getting to the inverse?
Everything in a bracket over 2.
-3 over -2, 4 over -2, -1 over -2, and 2 over -2. Remember, guys, there's a shorter way to do this now. I'm just choosing not to do it. All right? Because if I use the word hence, chances are something we do before could have helped us to get to the answer faster. But they gave us the option of what? They gave us the option of what? Otherwise. So I have a choice if I want to. So break down this now, we all get nice and neat. +3 over 2. Then 2 you can cancel and get -2. This can come down to nicely a half. And this can break down to become -1. That's the inverse. So it doesn't feel, it feel like it worked more than 2 marks, but you see, as long as we get the 2 with them assigned to it, we don't care how long it take, as long as we get it. So that is the inverse. All right, so is it safe to say that everybody somewhat, you know, not everybody. Is it safe to say that you guys are comfortable with, if you see the word inverse and matrix, you can manage that?
Yes, sir.
Yes, sir.
Yeah, man.
Yes, sir.
Mm-hmm. All right. So we get that now. Now it says what now? You must use the inverse of this thing. You hear them say? Use the inverse. They might try to say use the answer where you just get a while ago. Use the answer to solve for x and y. And see the same thing come back. Remember the a x something equal b, what we talked about earlier? Let me go back up here so again, show you the questions them connected. I know you remember, but I want to show you them connected. The very first question that we approached, right? Remember the ax something, see there again, you see it? See that come back with the ax equal b something up here, so? You see connected? Same thing, I'll come back. It you call simultaneous equations using matrices. So if them say it to you in the exam next week, Tuesday, say use a matrix method, I hit them attack. If them say use a matrix method to find x and do not. In fact, you know what? You see, whenever you come down to the base, just look out for the setup here. Look out for this setup right here. So once you spot the setup there, just know say x, which is this matrix right here, is equal to the inverse of the first matrix times the second matrix. Just remember that. All right? But we don't find the inverse of this. Watch the big question now. Big question come up. We don't find the inverse of that, 12/7. So we're saying that, watch now. We're saying that xy is equal to the inverse of that something times B times B, yeah, times B. All right, so the question now, look, we already have the inverse of this, you know. See it down here, so. The question that I'm have to ask you now, to make life easier.
Use the half, the 1 over negative 2 times A.
Brother, could you me ask a question, brother? Jesus, peace, oh God, brother. I was about to ask before Javari bust the secret. Are we going to use this one or this one? All right, since that's in bust the secret, why am I going to use this one and not this one?
Yeah, times 1 I bracket first, and then after you get that, you times it by a half. It's complete.
Right. It's easier. Most persons don't really like fraction. And when I say most persons, I not say everybody. Say if the cap doesn't fit you, don't put on the cap. If you like fractions, you can go ahead and use that one. Right? Me an old school type of mathematician, you know, so. My skill set come from back in the old tens. Right? In the early 2000s, that's when I learned my style. So in them time there, a whole heap of shortcut style we used to use. We never used to go the long route. Right, so we use whole heap of shortcut style. So we're going to use this one here. So this is not the complete inverse, you know. That is just the inverse of the matrix in its scalar form. And when you have it in the scalar form, you work with whole numbers. It's easier that way there. Well, my opinion. So go say A inverse is 1 over negative 2 times negative 3, 4, negative 1, 2, and then we go times that back by 12/7. Come on, say a matrix B, you see there, the 12/7. Okay, so that's the matrix B, right? So 12/7. When two brackets join together, what do we do?
Multiply.
I'm almost tired of me now if you ask the same question.
Row by column.
Row by column. I row by column that now. We go right 1 over negative 2 times. Samara, come in.
Sir?
Come, row by column.
Negative 36.
96.
Negative 36 plus
21.
28. All right, row now by
28.
column again.
Sir,
Row
I
by
get 28 from...
Negative 12.
Samara,
7
negative
times 4,
28
Samara.
times 12. That's all. And then second time,
Negative 12.
Samara.
Oh.
All right, negative 12, yeah?
14 plus 14.
14. Mm-hmm. Work out that now. So we're going to end up with 1 over negative 2 times
Negative
8.
8, yeah.
And what is negative 12 plus 14?
2.
2. So that works out nice to be. What is a half of negative? What is a half of 8?
4 and 1.
4.
So the two negatives cancel. What is a half of negative 2?
Negative 1.
Negative 1. So therefore, x is equal to 4 and y is equal to negative 1. That's it. Okay? And remember that separate and aside from this very, very long class, Miss Paddyfoot and all my other students, Shamir and person from my outside of this class, may have separate videos on this alone. So you can always zoom, you can always go back on the thumbnail will tell you what to look at. And you just fast forward up to that section there if you want a little personalized version on this alone. So make sure you make jottings of the things that you need to review when I'm not beside you or I'm not with you. Okay?
Okay.
All right, cool. Boom. All right, so that the question is done. I have one more question in my body. Me now go till 10 o'clock. Sorry, we do not doing that. Me have to let some of the questions on the practice on your own. So this last one here, let me look at the rest of them now and see if you can manage them. Yeah, man. So look, so we are gonna do this one now. One more, what you call it? We're gonna do one more vector algebra and something there, and then I'm gonna left some of them for you know. So see there, see the ax equal b something again. See it here, ax equal b. Oh, by the way, hold on. Let me double check. Let me double check. How do you get this thing to go back into this form? This want to make sure I check this here. You realize that every question I give you so far, they've actually had it in that form. How do we put it into that form?
Sir?
Yeah.
Are you gonna put it like 4x over 2y equals to? I don't know.
No.
I don't know.
Create two
Somebody else,
separate
Darren.
equation.
Separate the equations, them.
Yes, sir.
How would do that? Yeah. So tell me.
So that multiply the 2
No,
and the
sir. Wrong.
3.
Hey, stop. Somebody else. Me no want you say nothing more, so you go to foolishness. Come. Somebody else.
Sir,
Yes, Matt Knight.
you would take the numbers and put it to itself.
So you tell me the numbers then now.
4,
Mm-hmm.
-2,
Mm-hmm.
2,
Mm-hmm.
3,
Mm-hmm. Then what me put in the bracket?
and then I put X and Y there.
And then what me put for the third bracket?
0 and 4.
Very good. Make sure you don't catch that, people. So far, you realize that they've always given us, so the examples that we've been doing since we're there, they've always given us this. But see them chuck one point you here with a you have to put it into that form. So remember now, people, whenever you're putting a simultaneous equation in a matrix form, you take out the numbers, Miss Paddyfoot, and put them in a bracket by themselves, make them into a matrix. Then you're gonna take the X and the Y and put them in a matrices by themselves like that and like that. And then you're gonna take the 0, 4 here and you're gonna put it into a matrix like that. Make a note of that, please. Okay? So we just want to make sure me telling you that before. So this matrix here, when I see OP already and OQ and PQ, you know, PQ, you go turn it backwards and subtract. So yeah, man, you can go have fun with those. All right, here's now matrix product. I don't know how to row by a column already. I already explained to you how to know when time matrices can be multiplied. All right, and I think you're gonna meet up on that over the weekend as well. I don't know about A inverse, right? These are the only thing that I haven't done or reminding about. But I will remind you guys on Sunday. I'll remind you about what is called singular matrix. Make sure to remind me Sunday to talk about singular matrices. Somebody from out of our 46, 44 persons, please remind me Sunday. If we don't see a question on singular matrices, make sure to remind me about it.
Sir,
Oi.
what me ask you now is
Yes.
Sunday marathon, the data go up into everybody?
Yeah. Well, no. Listen. All right, so it's going to be open to the day school students. The students that I have not been seen at all.
Sir.
Uh-huh. We know what that means. It is still a class that you have to pay for. It's just that there are a few students who kind of send the link out to, right? So yes, it's still a class that you have to pay for, right? But it's just open up to some students that have never been to a marathon, and technically some of them can't really afford to be there, so I have to open it up to them. All right, I don't want to leave anybody out, but it's still a class that you have to pay for. So for that, yeah, about.
Sir.
Oi.
So like when we can't afford it, we can go for free then.
Moving right along, ladies and gentlemen. So please remind me on Sunday to talk about singular matrices, okay? All right, let me see what I'm going to do yes or no. Just want to make sure I'm not leaving with no question. We go bold no physics. A, B, or AC, you don't know if you turn that around and turn back way. So that singular something here. Please remind me on Sunday to talk about it. All I'm going to remember still about. Please remind. In fact, you know what, Shamir, I'm leaving that responsibility up to you here. I mean, I can't trust them people in our class here.
I will be late on Sunday because I have to work.
Javari,
they won't give me the day off.
Oh, Jaja. All right.
I deal with it, sir.
All right, do deal with it. And see on have the little vectors and something down here. So they can go and practice them thing, right? Yeah, man, hold back question. I can't spend all the time working every single question for you. You're gonna have to do some on your own. Yeah? All right, do. So one more question in the bag, and we're out of here. In fact, you know what I should do? I should really make a decide which one I want me the phone, you know. Is that a better choice?
Yes, sir.
Should I let you guys decide? All right, so because they have to go scroll and show everything. No, sir.
Just be the one with less question.
Samara, you're not a part of this. You're not supposed to make any opinions on this because you only one guy here bed go sleep, sir.
Oh, okay.
All right, let me see which one I should. I want to choose one where me know say can bring out something else out of the bag.
Choose that, sir, right there.
That one here?
The trapezium.
That one here?
Yeah.
You want that one there?
Yeah.
Yeah, man. So that one.
You know, matrices, you know? Yeah, I want to look at it, matrices. But all right, we'll do that one here then. Sure?
No, not that.
Trapezium, man.
The trapezium one.
Trapezium one, that one,
yes.
You know? Yeah, but me after the trapezium one connected to this up here, so. One question,
You
you know?
that?
No,
yes,
sir.
Yeah,
That's the other one, no other one.
All right.
Same.
You connected the vectors and matrices together. All right, so do you want to do this one, A, B? All right, this here, A inverse, simultaneous equation, and then we have one little vectors, yeah, so. And I want that one there? Look on the good if you don't want to do it.
The last
vectors, yeah. Because simultaneous, so. And you can get one extra practice over the simultaneous and something there, so. Or no one do that one here. No, so that one not too long. That one long? Yeah, hold on, 11. That one having, so do you want me to do an example just in case you guys don't make it on singular? Or can't figure that out? And have to tell me now, guys, before we decide to move on.
So I did the second to last one.
Second to last one.
Yes.
Well, I'm more test. That one, I only can't do that one here. I'll be wasting my time if I did this one. Me not lie. So me not do that. I can't do that to myself. This one not really have much. I'm having a hard time deciding which one to do. Because they
with singular.
Do they one with singular?
Yeah, and everybody can afford the marathon, you know, so we better we'll just take what we can get from them.
Alright, so we do the one with the singular then and then call it that. Alright, this last one then. Alright? Cool. Let's go. Ready? Last one, people. Let's get out of here. No Simonia. You have to pay for the marathon. No, man, remember, when I say free, people, it is open to the persons who come to the day school and I have not seen them. It's not like Mega send the link. Remember, the link is going to change, you know. The link for Sunday is different, you know. So that link will be sent to the students and I'm say none at all, any at all. If you notice that I have, look in the chat, there's 43 persons now, right? And yesterday was 59, 58, 57 persons. You know what person registered for the maths at MI? 216. Where are the other 100 and odd persons? They have no interest in passing this subject this year. That's just the reality. Are they not available? Or I don't know. So you see the population that we have, we are only getting 1/3 of the, and a couple persons are from outside. So 1/3 of the population that I have at MI, 2/3 of the population is not here. As a matter of fact, 75% of the population is not here. All right, cool. Last one. Let's get out of here. All right, moving right along. The position vectors points A, B, and C. No, sir. We're not do that. That's too easy. Sorry. We're not doing that. Nope. That too easy.
There's my way to triangle.
That one too simple, man. You know what? It's all right. Cool. It's fine. The position vectors A, B, and C relative to the origin O are that OA is 2, negative 2, OB is 6, 1, and OC is 10, 4. We've seen something like this in our previous example. Expressing the form XY. So, Buckingham?
Yes, sir.
XY like that, down, then right answer.
Yes.
What if AB? It's alright, no worry, no worry. AB is what now? Turn it backwards, subtract. What we're gonna get?
B minus A. So I got
B
6,
minus
1.
A. So we have 6, 1.
2, negative 2.
Minus 2, negative 2. Answer? 6
So I
minus
have 4.
4.
Negative 1. No, 1. No.
No. 1,
3.
negative 1. 3.
3.
Alright, 3. Correct. So AB is 4, 3. Everybody good with that?
Gucci.
Alright, Gucci. AC now. What's the formula for AC?
C minus A.
Yes, Geneva. See you. C minus A.
Bro, let me see the thing there.
Yeah. So C is 10, 4. C is 10, 4.
Yeah, 2, negative 2.
2, negative 2.
So I got 12. No. Yeah. 8, 6.
8 and 6. Alright? Cool. Alright, Shamir, quick. Just a random question. They didn't ask, but if I'm to ask you, what's the relationship between A, B, and BC? Give me one relationship between them. Just testing to see if you remember.
It's twice.
What is twice? Be specific.
AC is twice AB.
Alright, or you can say AB is half of AC.
Okay.
Alright, good. And what's the other relationship?
I'm guessing they're parallel.
Correct, Samara. Yes. Not guessing, you're right. They're parallel. Alright. Alright. Are we gonna do this one?
Sir, skip that one. Skip that one.
Oh, so not doing that one? It's a lot
Sir,
easier.
I would like to
Boss.
skip that question
Let's skip
for
that one.
tonight. Skip it for tonight. Yeah, tomorrow we'll do that.
No, tomorrow we're doing statistics. Sorry, tomorrow we're doing circuit theorem and trigonometry.
Sunday we'll do that.
Alright.
One next year.
Determine the values of x. Determine the value of x for which the matrix 3x24 is singular. Jot this down for me for those who don't have it. Or if you have it again, jot it down one more time. So you remember, a singular matrix is a matrix. A singular matrix is a matrix. A singular matrix is a matrix where the determinant is equal to 0. A singular matrix is a matrix where the determinant is equal to 0. So whenever you see the word singular, people, in the future, you're just going to take AD minus BC and make it equal to 0. That's what you're going to do. Let me reiterate that. If you see the word singular on your exam next week, Tuesday at 9 a.m. in the morning, you're simply going to take the formula for the determinant and set it equal to 0.
And then you divide it out like one.
Just work out it normal. What is A? What is B? What is C? And what is D?
Yeah, but you have to get X by itself.
Yeah, but you don't put it in yet. So what is A?
So A 3 times 4.
4 minus
X
times
2
equal what?
0.
3 fours are what?
12.
And X times 2 is?
Minus 2X.
No, you're going to try to get X by itself. No.
Yeah, carry over the 12.
So you end up with negative.
Make it negative.
So we're actually transposing, right?
Transposing, yeah, correct.
And then I go divide by 2.
X are equal to negative 12 divided by negative 2. X are equal to 4.
6.
All right,
Yes,
6.
right.
God have
6.
mercy. 6. That's it. All right. Now, just to warn you,
Not so bad.
I mean, it's not hard. It's just that it's such an uncommon question that students, when them see it, it's like them just leave it alone. It's a report come out from CX, that the question with them send back most often is the question that students keep on skipping out. Why do you think circuit theorem come every year? People don't like it. So they keep sending it back, and them not stop sending it until they start master it. The moment them pick up, so everybody start understand it, they must stop sending it come.
Alright, sir. So that's how we get the circular matrix now. Have a good night.
Oh, you're gone. You're not going anywhere. You're not leaving me. I'm watching and chatting. Do not go anywhere. We're not done. All right. Now, what's another name for singular matrix? It's when the matrix does not have an inverse. So if on May 12, next week, Tuesday, you see, find the value of x for which the matrix does not have an inverse, are the same thing as singular. So when it has no inverse. All right? No inverse. Okay? By the way, I'm tired, guys. I'm not managing by myself. Oh, God, I'm tired now.
Yeah, man, yeah, man.
NP. Oh, God, I'm tired now, man. NP.
Yeah,
You can't do row by column and inverse something there.
You can just do it now, man. Hello, man.
Good
Tired now.
night.
Hey, yo, big up yourself, yeah? Tomorrow
Yeah,
again,
man.
6
Bless
p.m.
you.
sharp. Sugar the Mitch and Circuit Theorem tomorrow. So big up yourself. Tomorrow we'll link up.
Alright, sir.
Excuse me, sir.
Mm-hmm.
Sir, I still haven't got added to the group. I had sent you a message, but you still not add me.
What this sound like, so? Zahenia?
Yes, sir.
Zahenia, you're already in the class group. Hey, me.
Okay, sir.
I see you in the group all the time.
Okay, sir. Okay.
All right. All right, people. Big up yourself. Be outside.
Sir,
Oi.
why document the way you say I send 2D now?
Listen, I'm tired. I'll try to send it as soon as I can. My
Okay.
God.
Sir, I see you tell us to send the document. Yes, as I come up the class, I'm going to send the document.
Promises are comfort to a fool. Good night.
Sorry. All right, sir, later.
Good night, sir.
Good night. Good night.
Good night.
Bye, Shamir. Bye, Miss Gentle. Big up yourself.
Hey, boy.
Mm.